Thank you. Thank you very much. I am happy to be here. How is it going? Okay. What are we doing? We are looking at the abacus. Here is my abacus. What we're doing is we're understanding how to read the abacus. When we read the abacus, we're going to count 1, 2. So this is 2. And then we have 3. This is 3. And then this is 4. And then we have 4. This is what 4 looks like. 4, when all the beads are touching this horizontal bar, is now considered 4. Now what do? We have 5. We have 5. Well, 5 is going to be the top bead. The top bead touches this. That's what the top bead is. So that's 5. If we look, all of these beads are not touching. They're not being counted. Only being counted is this right here. This is the 5. So if we look, I don't know if this is going to help. We talk about the ones place. So we have 5, and then we have 6. 6 looks like this. That's what 6 looks like. And then 7 is that. 5, 6, 7. And then we have 8. 5, 6, 7, 8. And then 9. 5, 6, 7, 8, 9. So if we look, we have the ones, the tens, the hundreds, the thousands, and the 10,000s. Hopefully you guys can hear me. I'm not sure what's going on. Okay, so what are we doing? We are learning how to read the abacus. After we learn how to read the abacus, we will be going into adding, subtracting, multiplication, and division. But the first thing we're going to do is understand how to read the abacus. So, how are we doing? How is everybody doing? Thank you for joining. Thank you for joining. If you have any questions, let me know. So, after that, what do we have? We have 10. We know what 10 looks like. So, if I line it up, this is 10, right? If we line it up, this is 10. Oh, maybe I should do this instead. So, if this is 10, ones and the tens, right? Ones and tens. So, when I look at that, right? 0, 1. That's what 10 looks like. What? That's so easy. I know. Simple to use, easy to understand. Let me know if you have any questions. Let me know if you have any questions. So after that, we have 11. So if I line it up, this is 11, right? We have 1 and 1. Just as how we read it is how we write it. Then we do 12. 12 looks like that. So if I line it up, the ones is the 2, the tens is the 1, and I do this, this is 12. Anybody have any questions? Let me know. Thank you for joining. Thank you for joining. HB, type in HB if you are a horizontal bar and you're tracking. So what's going to happen is this thing right here is the horizontal bar. This is the horizontal bar, and this horizontal bar is what tracks our numbers. So when we look, this is 0. None of the beads are touching this horizontal bar. So what's going to happen is when I do this, this is 1. How do I know this is 1? Because now the beads are touching the horizontal bar. The horizontal bar is tracking this number. And then we do 2, that's what 2 looks like, right? And then we have 3, that's what 3 looks like. And then 4, that's what 4 looks like. Yeah? Makes sense? So what we're doing is we're tracking the numbers on the abacus. And what? And then after we learn how to read, we will go into adding, subtracting, multiplication. So the first thing we're going to do is understand how to read the abacus. For those of you that don't want to be interested in learning how to read the abacus, that's what we're doing. We're learning how to read the abacus. So when we do it, we have 1, 2, 3, 4, and then 5. The top beat will always be 5. And then we have 6. Thank you so much for the hearts. 6. And then 7. Sorry, 6. This is 6. 5, 6. And then 7. Notice it's 2 beads. 2 plus 5 is, oh, thank you, she. 5, 6, 7, and then 8. We have 5, 6, 7, 8, and then 9. 5, 6, 7, 8, 9. Let me know if you have any questions. Shady? I guess it would be Shady. That's a funny username. So, let me know if you have any questions. So again, let's count it again. So we have 1. Notice when I have 1 and then I add the 5, now we have 6. We've done 2. We have 2. This was 2. And then when I add 5, now we have 7. We have 3. We know what 3 looks like because we've done 3. 1, 2, 3. When the beads are touching the horizontal bar, this is 3. 1, 2, 3. We add the 5. Now we have 8. We have 4. 1, 2, 3, 4. When we add the 5, like that, now we have 9. Let me know if you have any questions. And then we have 10. How do I know that this is 10? Well, if you look, where's my, there it is. we notice that if I did this, that looks like ones, right? And then now we do this, which is tens. Notice that we can start looking at place values. And that's one of the things that's really interesting about the abacus is it captures the place values. So here is 100. This is 1,000 and this is 10,000. When we do this, this would be 11,111. We could do this, which would be 5. All of these are fives. And then we have 0. This is all 0. We can do 2 or 20. We could do 200, 2,000, or 20,000. Let me know if you have any questions. Let me know if you have any questions. So what we're doing is we're learning how to read the abacus. After we learn how to read the abacus, we'll go into adding, subtracting, multiplication, and maybe division. It all depends on how fast or how quickly the class will be. So we have 1, 2, 3, 4, and then we have 5, 6, 7, 8, 9, and then we have 10. Notice that this is 10. So hello, Crispy Crusts. Thank you. Let me know if you have any questions because you're the only one here. Hi, I wish somebody taught me this. Really? This is what we're doing is we're learning how to read the abacus. We're learning how to read the abacus because then we can actually do some adding and subtracting. So let's do some simple adding. When we do 2 plus 2, that is equal to 4. Now, if you notice, I'm not memorizing what 2 plus 2 is. What I'm doing is I'm looking at the number. I'm looking at it, right? I'm looking at what this is telling me. So when we read the abacus, what we're trying to do is we're trying to see what the numbers are. So if you look, thank you, Vale. Thank you so much for the likes. Thank you, everybody. And thank you for commenting. I do wish I can be of service and provide how we do this. So this is 6. My question is 6. 6 plus 2 is equal, no, 6, right? Now my next question is do I have enough beads to add the 2? Is there enough to beads? Yes, there is enough beads to add the 2. These are the 2 beads I'm going to add. So I'm going to add 1, 2. That's it. That's it. It's the easiest thing. We don't need to memorize doubles. We don't need to memorize doubles plus the strategies of adding doubles. I don't know what that is. So here we have 5, 6, 7, 8. 5, 6, 7, 8, and then we have 3. So notice if I take away the 3, if I take away the 5, we have 3. When we take away, we want to subtract, we want to go away from the horizontal bar. When we add, we want to go to the horizontal bar. So when we add, we move the top bead up. We move the bottom bead up. So this is 1, and then this is minus 1. So if we add 1, this is 9. We want to take away 1. Now we have 8. Notice? So what we're doing is we're adding 3. When we have 3 and we want to add the 1, I'm adding just this 1. That's what I'm doing. So here my question is, notice that we're only focusing on the add-in. When we focus on the add-in is what it is. What we're doing is we're trying to understand the journey, right? We were talking about the journey and not about the destination. So it's always about the add-in. When we look, we want to add 7. We have 7 on the abacus, 5, 6, 7, and then we add 1. We have 1. So this is now 8. We have 2, we have 1, and then the question is there enough bead to add another 1? Yeah, there is. That's not a problem. So here my answer is 2. When I look, I have 3. So notice it's starting to get bigger, right? But this is going to be easy. Why? Because I have 5. I'm going to add 5. This is the top bead. This is the 5. Now, if anybody has any questions, let me know. Can you show the sum higher than 10, such as 8 plus 8? Yes, Mackie, I can. But using the 8 plus 8, we're going to have to start knowing how to do formulas. Formulas, which means that we're going to have to understand how to make a 10. So the one thing is to understand how to make a 10. When you know how to make a 10, then we can actually go on further. Are we ready for that? Do we want to know how to do that? Here's a question. If I had this number, right? We have this number. What number is this? What number do we know that this is? So Mackie, before we go into what 10 plus 10 is, or I'm sorry, how to make a 10, we're going to do first thing is understand how to make a 5. And then we'll start to build up, if that's okay. Is that okay? Hopefully you're still around. If not, then we're going to continue on adding. Yes, thank you, Jesse. Yes, it's 284. Exactly. Okay, so it sounds like that we're ready for the next lesson. The next lesson is how do you make a 5? Thank you, Mackie. Thank you. Oh, you're still here. Good. So the first thing we're going to do is we're going to understand how to make a five. This is what we're teaching the kids. We're teaching the kids how to make a five. Why are we teaching the kids how to make a five? Well, I don't know why we're teaching them, but in Abacus World, it's fantastic. You know why? Because in Abacus World, oh boy, in Abacus World, we have 1 plus 4 is equal to 5. Because 1 plus 4 is equal to 5, that's what we're teaching the kids. Now, why are we doing that? Well, I don't know why we're teaching it, but it's an easy. I think they call it a friendly number. So if they call it a friendly number, what we're going to do is we are going to modify our addition sentence. We're going to Okay, so what we're going to do is we're going to modify. What does that mean? Well, the first thing we're going to do is we're going to isolate the variable. Why are we going to isolate the variable? Because the question is, and I'm going to continue on. What we're going to do is we're going to add a four. Now, if you notice, when I add a four, I don't have enough beats to add a four. So what's going to happen? What? When I do this one, let's do three. Let's do three, and notice the abacus actually provides restrictions, constrictions, restraints. So this actually helps us to understand how to use the five and adds more critical thinking. Why? Because what we're going to do is we're going to isolate this variable. Why are we going to isolate the variable? Because we want to add the four. Again, what we're looking for is the add-in. Because we're looking at the add-in, we want to isolate this variable, right? How else do you do it? What else do other people do it? When they teach the kids, they go by number lines, right? They do 3, 4, 5, 6, 7. We could do number lines. But in Abacus World, we don't need to do number lines. In Abacus World, we have this formula. We have this concept. So what we're going to do is we're going to isolate the variable. When we isolate the variable, we have this equation. 4 is equal to 5. Because 4 plus 5 equals to 5, that doesn't make sense. How do we balance it? To balance it, we want to minus the 1. How does that work with the abacus? To work with the abacus, we have the 5. Now we're given direction. We add the 5 and we take away the 1. So my final answer is 7. So instead of doing the number line for 1, 2, 3, 4, what we're doing is we're using this concept that we're teaching the children how to make a 5. Does that make sense? How are we doing? Does that make sense? So let's do it again. So instead of memorizing, we've memorized 4 plus 4. We've all memorized what 4 plus 4 is. But in Abacus World, we don't need to memorize 4 plus 4. How do we do this? Well, if you look, we have 5, right? We have 4. When we add the 4, we want to add another 4, right? We want to add another 4. When we add another 4, 1, 2, 3, 4, I don't have any more beats to add the 4. What's 2 plus 2? Hold on. Let me finish this. So when I want to add the 4, okay, there's not enough beats to add the 4. So what do? I'm not going to memorize 4 plus 4. I'm going to memorize this concept. This is a 5 concept. When we add the 5, we notice that we're not going to have any freeloading 5s. We are not going to have any freeloading 5s. So what does that mean? I'm going to I'm going to add the 5 and I'm going to take away the 1. So my final answer is 8. This will feed into your question, Mackie. So when we look into it, we have this concept. This is a concept that we're doing, right? Now we could do it again. Let's do it again. We can do 2, right? And again, when we do 4, we don't have enough beats to add the 4. So AJ, you have 2 plus 2. Is there enough beats to add the 2, AJ? I don't know if AJ's still around. AJ, hello, Neon. Welcome back. You're not at a birthday party, are you? You should not be at a birthday party. Hi, good. AJ, can we add? Can we add a 2? Yes or no? AJ, yes. So this is all I'm doing. That's what 2 plus 2 is. That's it. I don't need to add any formulas. How come we're starting at the Thank you, Jennifer. Yes, thank you. Jennifer. Hey, Melinda, welcome back. So, Jennifer, that's a very good question. The reason why we're here is because I have this dot indicator. This is my ones indicator. This ones indicator tells me that this is the label. This label, thank you. Thank you, Mackie. So this is my ones indicator. It's a label. This label tells me it's the ones place. So when I line it up, I can do that, right? Does that make sense? Now the question is I have 2. I have 1 here, I have 1 here. But notice if I choose this one over here, I just move all my decimal places over there. Does that make sense? So what are we doing? We're using the abacus for a place value. That's all it is. So if I do my ones, my tens, I don't have any more beads for the hundreds. That's why I choose this one, like a Pokemon. I choose you. Thank you guys for your questions. I do appreciate it. AJ, I'm very happy that you were involved with this. Thank you. Thank you. I wasn't sure if you were just kind of spamming or you know what I mean? Like, I don't know. But I'm very happy. Thank you. So, AJ's question, just so you know, we have a two. Let's say we want to add a five. When we want to add the five, what do? Is there enough beats to add the five? Yes, we can. So we're going to add the five. All we got to do is add the five. That's all we're doing. Thank you, Neon. So what we're doing is we're just seeing how many beads we have. Now, the next step is to understand when we don't have enough beads, and that's why we're doing this. That is why we're doing this formula. We are doing this concept. This concept is how to make a four. Well, what about is that it? Is that all we're going to do? No. There's a whole set of how to make a five. Sunny, we'll have to put that on hold. Can we put a pin in that? Because that will be the next step. Wait, what is the value? Yes, Kira, the top bead will always be the value of five. I just bought an abacus from your link. Oh, thank you so much. Thank you. When you add the blue bead, it's equal to 9. When you add the blue bead, that's what I'm adding. So if I did 4, I have 4 and I add the blue bead, that's where your 9 is. Yes, that is exactly what it is. So, Sunny, we're going to put a pin in it. We're not there yet because Mackie had the question as well. And that is when we start doing the tens. But the first thing we need to do is understand how to make a 5. Is that okay? So, what we're doing is we're understanding how to utilize the 5. Good afternoon, Beal. Welcome back. Taking a little break, I hope. Good. Well, yeah, so what we're doing is we're making a 5. Does that make sense? So now we have a set, right? This set is we can do another one for the 3. Let's do 3. What? Why are we going to do 3? If you notice, when we do a 3, again, let's do 4 because it's easier, right? We'll do 4 plus 3. Nope, that's not the right one. We'll do 4 plus 3. Again, this is the concept. Hello! This is the concept. 3 plus 2 is equal to 5. Well, what are we going to do with it? What we're going to do is we're going to isolate this variable. Why? Because when I have the 4 and I want to add 3, there's not enough beats to add the 3. So what do? Yes, I've been studying for my pre-nursing. Oh, good job. Hey, there's a few people that you should follow. I think Blessed RN, and they will help you with your thing with measurements and stuff. Let me see if I can find that information if you like. Yeah, my friend Audrey has, and she follows a few people that does RN stuff. Thank you, Melinda. Yes. So what we're going to do is we're going to have the 3 and it's equal to 5. But notice this is not balanced. So what we're going to do is we're going to minus the 2 is the best. Yes, Blessed RN is the best for calculations. Yeah, great. I will. Yeah, I think I. If you want the person, Beal, let me know, and I'll ask my friend about it. So again, yeah, I need all the help I can get. Yeah, she's really good. That's what I've been told. And even Jennifer said. So again, what am I going to do? What am I going to do? I'm going to add the 3. To add the 3, I have directions. I want to add the 5 and I'm going to take away the 2. So my final answer is 7. Is that making sense? Thank you guys so much for the hearts. Is that making sense? Okay. So I know somebody said no, but I don't know if they're here anymore. Okay, how are we doing? Are we doing okay? No. No, we're not okay. What about when we don't have the answer to the equations and then what? Yes. Yes? No, not really. Kira, I don't really get it. Okay, wait. Jennifer, what about when we don't have the answer to the equation? How is it 7? Kira, this is 7. 5, 6, 7. The top beat is 5. So when we look, 1, 2, 3, 4. Let's do a little review. This is 4. Kira, does that make sense how this is 4? Right? Does that make sense how this is 4? Okay, wait, hold on. I need to understand if you know how to read the abacus before you do that, right? And then we know how to do five. This is five. Do we know that that's five? Right? We add the five. We have five, and then we do six, and we have seven. Okay, good. Eight, nine. Okay, good. Okay, so how is this four? Well, what we're doing is we're going to add the four. Jennifer, hold on just a minute. So let's say I have a question, right? I have three. I have three. And I want to add five. I want to add four. So what is my question? My question is no, actually, Jennifer, this is one, this is one, this is one, this is one. Because what we're going to do is when we take away, this is take away one. If I have three and I take away the one, this is not two. Make sense? If I take away one, if this is two and I take away one, I'm only taking away the one bead. So every value of the bead, it has nothing to do with the color. So if I changed it, let's change it to this, right? It makes more sense because I have one, two, three, four. Now, if I take away one, I'm not going to take away the orange bead. What I'm going to do is I'm going to take the one bead. If I want to take away two beads, I take away two beads, and that's what I'm doing. I'm moving two beads, right? If I have four and I'm going to take away three beads, whoa. If I take away three beads, it's one, two, three. I'm going to do this. Does that make sense? Okay, Kira. So let's go back to the question. How do we do the four? Okay, Jennifer, the colors don't mean anything. Yeah, the colors don't mean anything at all. So I just use the colors because it looks pretty. Yeah. So here, when I add the five, this is the top beat. This is five. Yep, yep, yep. And then this is six. This is seven. This is eight. This is nine. Yeah, I just use this because it's pretty. Some people are colorblind, and that's not an excuse. It's all about the positioning of the beads. So if you notice that the beads, anytime the beads are touching the horizontal bar, that's what's being counted. So we look at the beads, and if it's touching the horizontal bar, that's when we know it's being counted. So this is 9. If this is 19, and then we have 29 and then 39 because these beads are touching. Notice I have a dot here. This is the dot. We have the same thing. The dot indicator is my ones indicator. So I go back and I go like ones, tens, hundred, thousands, 10,000. When we look, every grouping is a group separator. So when we look, we can move it to here if we want to, right? If we want to, we can start from here. If we start from here, then this would be my place value. Ones, tens, hundred thousands, 10,000, 100,000, million. This is a million. 10 million, 100 million, billion, 10 billion, and so forth, right? Does that make sense? So when you count up to 10, you move. Yes, exactly. So what we're doing is when we count up to 10, right? Just how we write. We have our 1. This is 9. Then after 9 is 10. What is 10? 10, when we write it, looks like this. When we write on the abacus, or when we read it on the abacus, it just looks like that. Can you do multiplication on the problem? Yes, I can. But before we go to multiplication, let me explain the adding and subtracting. That's cool. I'm starting to get it. Yes, right? Uh. That's cool. Okay, good. Yes, you can't do 10 in one row. Yes, you have to use two, right? You got to use two columns because it's two digits. Each column is a digit. You only go up to 9. So this is 19. How do you do 20? 20 is 2 and a 0. I get better. It is better. I just did that one. So does that make sense? Okay. So the next thing we're going to do is we're going to understand. Thank you for the follow. What we're going to do is what are we going to do is we're going to understand why are we adding the 5. So here if I go back to here. Now, sometimes it would be helpful to have different types of props. So let's say I have 4. If I want to add the 4, I have 4, right? Kira, are you still here? Okay, good. Kira, so when you look, I have 4 on the abacus, right? I'm going to give you 4 pennies. I don't know where you are, but penny is worth 1, right? 1, 2, 3, 4, right? I have 4, right? The thing that I want is worth 4 cents. Another 4, another 4. If I want to give you another 4, but I only have a nickel is worth 5 cents. If I only have a nickel and it's only worth 5 cents, what am I going to do? I'm going to give you the nickel, right? I'm going to give you the 5. But 5 is too much. You give me back the change, which is 1, and I take away the 1. Does that make sense? Subtract the 1. Yes, exactly. Subtract the 1. Does that make sense? So what did we just do? What we did was this formula. What we did was this formula. That's what we were doing. Yes. Good. Yes, good. Good, good, good. So what we're doing is we're trying to understand how to use the abacus. And what we're doing is my frontal lobe has developed. 420, if you're going to continue to spam, I'm going to block you, just so you know. Because I'm done with all these, like, whatever these things. Okay, does that make sense? Yeah? Yeah? We're okay? All right, so that is, I've never learned this pretty cool. Oh, thank you. So that's what we're trying to do. When we do this, we do 3 plus 4. It's the same thing. I have 3. I have 3. If I like the live, is it considered spamming? No, 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 no. It's the comments that I see in the top. 420 is doing something with all these emojis. That's what I see. Do you not see that? No, Kira, you're fine. You're fine, Kira. Okay, so how are we doing? Does that make sense? So let's do this one, right? When we do this one, we have 3. 1, 2, 3. I'm going to have 3 on my abacus. When I have 3 on the abacus, it's the same thing. I want to add the 4. I see. It's annoying, but luckily there stops. Yeah, yeah. Yeah, I see those too. And I'm like, okay. I mean, it's funny at first, but then after a while it gets annoying. Okay, so I'm adding the 3. I already added the 3. I have 3 pennies. 1, 2, 3. I want to add 4. To add the 4, how long have I been live? Just a half an hour. Yes, thank you, Jennifer. I want to add the 4. So I have 1 nickel. I have 5 cents. I'm going to give it to you, but it's too much. I'm going to give it to you, but it's too much, right? I'm going to go to the 5. It's too much. So I need to take away the 1. I need to take away the 1. So my final answer is 7. So what we're doing is we're looking at it and we're seeing we're adding and subtracting. Understanding the basics, right? Because now this goes further. We have the same last name. So what we're trying to do is we're understanding the basics. This is very simple, right? But to understand the basics, and then it can scale. So we're done. We understand this part. Let's do the next one. Yes, let's do 8 plus 8 first, right? Let's do 8 plus 8 because Mackie, I don't know if Mackie's still here. We'll do 8 plus 8 first. Can we do that first? Thank you for the follow. Okay. So what are we going to do? Well, we had this one, and now we're going to do 8 plus 8. What are we going to do? Why are we going to do 8 plus 8? Well, 8 plus 8. That was one of the questions. That's how it all started. So it all started because somebody was asking about 8 plus 8. Well, then what are we doing? Well, if you notice, do I have it? Yeah, that's the one. All right, 8 plus 8. Again, what are we doing? We understand this concept. 2, how do we make an 8? 2 plus 8 is equal to 10, right? 7 plus 3 is equal to 10. We're going to be doing this. Do you use the bigger abacus the same way? Yes, exactly. It doesn't matter. It just matters on how big the numbers is. 4 plus 4. 4 plus 4, we go back to here. 4 plus 4 was one of these. If we need to add a 4, we're going to use the 5. We don't need to add another 4. So what we're doing is plus the 4, right? We have the 4. We add another 4. What are we going to do? Plus the 5 minus the 1. So we're going to plus the 5 minus the 1. And my final answer is 8. So, Dago, did I just 5? Yeah. The 4 plus 4 will always be 5. Hold on, Kira. So the first thing we're going to do is understand how to do the 8. So what is the question? The question is 8 plus 8. We're back to here. Understanding this first. Let's understand this. So let's do 8. Here it is. 8. when we look at it, it would be 2 of what you just did. No, it wouldn't. Okay, good luck, Bill. I'll see you in my next life. No, it wouldn't be 5 plus 5. Why? Because it would be this, right? If you did 4 plus another 4, but then what would be the point of doing a 10? So what are we doing here? We're going to add the 8. Notice when we add the 8, right? We have the 8. 5, 6, 7, 8. We're going to add another 8. We know how to add an 8. We're going to utilize the 10. What does that mean? We're going to utilize the 10. Ooh, this is such a beautiful thing. So the first thing is we're going to do is we're going to understand how to make an 8. To make an 8, we're going to utilize this 10, right? The 10 is this column over here. We've done 10 before. What do we do? 5, 6, 7, 8, 9, and then 10. That's 10. Does that make sense? Because we're adding 10, we got to use this bead over here. So thank you, Neon. What we're going to do is we're going to minus the 2. So if we have 8, there's my 8, and I want to add the 8. I'm going to add 8 again. What do? I plus the 10. 1, 0, 1, 0, and I take away the 2. So my final answer is 16. Does that make sense? So that's the first one. Did that make sense? Okay, good. So here, I want to add the 8. Not a problem. When I add the 8, what I'm doing is I know how to make a 10. I'm going to learn how to utilize this 10. I learned how to make a 5, right? That's okay, Alex. Hold on just a minute. I learned how to make a 5. I utilize the 5, right? I utilize this 5. Okay, we're done with that. The next thing we're going to do is we're going to figure out how to make a 10. We're going to carry on. We're going to carry on. But notice, oh, do I have enough? 8. Oh, I have enough. I have enough, right? I have this much. I have 8. I want to add another 8. I'm going to add another 8, but I only have 10 cents. So what do? I add the 10, but giving you 10 cents is too much. I need to take away 2. Oh, sorry. That was my 8. Yes, you add the 10, but adding the 10 is too much. This is no longer balanced. So I need to, yes, and I will get the change back. I need to minus the 2. Yes. Yes, 2 cents. Yes, Kira. Makes sense? Does that make sense? Good. 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 So what are we doing? We're utilizing the abacus to help us understand how to add and subtract. So do 7. Yes. So we do 7. I'm sorry, 7. Right? To make a 10, thank you, Sunny, for the reminder. To make a 10, I need to do the 3. 7, there's not enough beads to add 7. 1, 2. I don't have enough beads to add the 7. So what do? If I need 7, where's 7? 7, right? That's 7. If I give you 10, it's too much. I'm going to give you 10 cents, right? 7 plus 3. Oh, sorry. 7 plus 3. Oh, yeah. No, I still need to give you 10 cents. But 10 cents too much. I got to take back this. That's what I got to do. Not 7 plus 7. It's 7 plus 3. The first thing we're going to do is 7 plus 3, yeah. How does an abacus work? I've never used one. Hold on, JC. Does that make sense, Kira? You're a pretty fast learner. Neon Panther's been with me for a while. This is not her first rodeo. Right? So what we're doing is when we add the 7, we're going to utilize the 10, right? That's why we do this. That's why we understand how to make a 10. When we make a 10, that's all we need to do. That is all we need to do, right? So what was the next one? So what we're trying to do is, oh, JC was asking how to read it. So we're going to review. Let's review. 1, 2, 3, 4. This is 4. And then the top beat is 5. 5, 6, 7, 8, 9, and then 10. Has it been a month? No way. I don't feel like it's been a month. I feel like it's just been like yesterday. That's crazy. Okay, so what's going to happen? So we do 11. I'm sorry, 11 is this. 11, 12, 13, 14, and then 15. Thank you, Beal, for the heart me. Oh, good luck. I know. I know, right? Okay. I think it's because I also have like my things. My what do you call it? When do you when I'm sorry. I love your teaching style. It's so fun and I'm learning. Oh, good. When do you do each live? I try to go once a day at least. Oh, I don't know, Neon Panther. Just so you know, just for everybody and Melinda. I don't know if Melinda's still here. I just want to let you know next week I'm not going to be live because I'll be in science camp. I'm taking my kid to science camp, and so I'm going there to chaperone. So I will not be here for Monday, Tuesday, Wednesday, Thursday, and maybe Friday. So the next time I'll be back, what am I supposed to do? There will be no learning the abacus. Okay, I don't know. I don't know, but I got to put it in my little story saying I won't be around. I apologize. I apologize. And I can't take any. I can't take any. What do you call it? Devices up. I never learned this at school. How did you learn this? 1550. I learned it no, truly it's not. Oh, you know it is. 1550. Yes, you're right. You're right. You're right. Yeah, I guess you'll be doom scrolling. Yes, you're right. Truly yours. 77. Yes, 1550. 15 1 5 and then 50 50. Yes, because we have the decimals. I learned this I learned this when I was old. I learned it because my dad wanted to open up a learning center. And so he told me, my brother and I, to learn the abacus so we can open up a learning center. And so I've been teaching abacus for about 20 years now, but I just started doing this on the internet, and so I have a few workbooks that I've created to try to help understand and try to spread the word of the abacus. Are you a teacher right now? I'm a abacus teacher, if that's what you're asking. I'm not a public school teacher. I don't know how to. Where do I buy these books? I do have it available on my shop or the other place. Hello, my name is Lynette. Thank you for joining me. I'm so happy to share abacus with you. And you know what? It's old. It's not new math. It's very old stuff. And so learning how to do it on the abacus, people just don't know how to do it. So we have this thing called new math, and some of the techniques of new math is very similar to abacus. So really, I think it's old math. But I mean, this is different than memorizing. So when I was going to school, I had to memorize everything. But when I learned the abacus, I realized I didn't have to memorize how to do five plus. I didn't have to memorize 5 plus 5. So I wish I was like in school. You're a great teacher. Oh, thank you. I appreciate that. If I can, I would like to, but for right now, that's not where I'm going. So my goal is to try to educate everybody how to use the abacus, and I hope that this is the greatest thing next to sliced bread. The reason why we're doing simple questions is so then we don't get bogged down with the bigger numbers, right? So there's a few numbers. I mean, we could do bigger numbers, but then you'd get confused. Let me do, okay, let's do this one. This will be easy. This will be easy. Now you'll notice that we have 200, and I did this one as a post. So this one is 283. We have 283. The abacus will come back thanks to you. I believe. I hope so. So here's the question, is 283. Can you see that this is 283? 283. Now what we're going to do is we're going to add 516. When we add 516, do we have enough to add the 5? Yes, we do. So we don't really need to do anything. We just need to add the 5. Is there enough to add the 1? Yes, there is. And I just add the 1. Now what I need to do is I need to add the 6. Can I add the 6? 5, 6. Can we do it? Yes, we can add. So when we add the 6, it's like that. So my final answer is 799. Yes, thank you. Easy, right? So what we're doing is we're moving the beads. When you move the beads, then it's the next step. Thank you, Jesus. So what I'm trying to do is I'm trying to show you that we don't need to do extra mental work when we look at our abacus and it's there and it's available, right? So here's another question, right? Another question was 34, take away 24, right? Take away 24. Is it easy to take away? Can we take away 20? Yes. There's enough beads to take away 20. So we take away 20. Can I take away 4? Yes, I could take away the 4. At one point, someone just made this up and people agreed. At one point, someone just made this up and people agreed. No cream of wheat, which is wheat. No, it's part of barter. It's after the bartering system. So, but you know what? That's what cars are. Somebody made up a car and we all agreed. Oh my God. Somebody made clothes and they agreed, or else we would all be walking around naked. At one point, somebody said 1 plus 1 is 2, and everybody agreed. Somebody agreed that Jesus walked the earth, and now we have Christianity. And at what, of course, if it made sense, then people will agree. Thank you, Trip. Right? That's I can't call you names. There'll be a violation there. User, welcome back. Welcome back. Okay. So what we're doing is, what are we doing? Oh, so I was showing you the small ones, right? I was showing you this one, 60. So we do 60, 60, 6 and 0. Thank you. So what we're looking at is, can we do it? So the next one was how to make a 10. We understand how to make a 10? Yes. The blue bead is the 5 bead. Yes. The blue bead is 5. Yes. So if I did this, this would be 55. Somebody somebody made expo markers and we're all buying it. Oh my God. I can go on with this. That was the most not very smart. Not a very smart comment. I'm so sorry. I'm stuck on that. Okay. Whew, I gotta move on. I gotta move on. Okay, what do we just that was not a smart question. That was not a smart statement. I'm sorry. Sorry. I cracked myself up. Okay, let's do this. Let's do this. Let's do this. Let me focus. Let me focus. Helen Keller was blind. I gotta stop. I gotta stop. I gotta stop. I can go on with that statement. I'm sorry. I'm sorry. Okay, 7. When we do 7, when we do 7, I want to add the 8. When I add the 8, what do? I don't have enough beads to add the 8. If you notice, I don't have enough beads to add the 8. So what are we going to do? We know how to do this concept. We know how to do 8 plus 2 is equal to 10. Sorry. Yes, Apple user. Yes, thank you for helping me stay on track. Thank you, thank you. I do appreciate it. So what we're going to do is we're going to plus the 10. We plus the 10 just as Apple user said, and we minus the 2. So when we do this, right, we're going to add the 5. I'm sorry, add the 10 because it's a 0 and a 1. We're going to add the 10 and we're going to take away the 2. All we got to do is take away the 2, and my final answer is 15. And I got to stop. So my final answer is 15. Yes, thank you. So my final answer is 15. She reminds me of my mom. I am a mom. Okay. So we have 4. We have 4. We want to add 8. When we add 8, what are we going to do? We don't have enough beats to add the 8. Again, we know this concept. For real in the best way. Oh, thank you. Okay. We want to add the 8. We don't have enough beats to add the 8. So notice if you look, we don't have enough beats to add the 8. So what's going to happen is we got to plus the 10. We add the 10 and we take away the 2. So my final answer is 12, right? My final answer. What's my final answer? I love that laugh. Thank you, Michaela. All right. What's next? Let's do another one. Thank you, Apple user. Yes, thank you. So let's do 9. When we do 9, it's the same thing. So what are we just doing? I'm showing you how versatile understanding the concepts are. I'm showing you how versatile it is to understand how to add the 8. Again, what we're doing is we're focusing on the add-in. When we focus on the add-in, hey, bleh, no, it's not 10 minus 1 because we're doing 8. So when we're doing 8, it's 9 plus 8. Hello, Mello. Mellow Maid. Thank you for the share. So we have 9 and we want to add the 8, not add 9. So what we're doing is we're adding the 8. When we add the 8, we want to do plus the 10 minus the 2, right? And so my final answer is 17. Yes. Yes. Yes, thank you. No, no. I mean, yeah. So so again, what we're doing is I'm showing you how versatile understanding this concept is. It's great that we're teaching the kids how to make a 10. But now what abacus does is we take it one step further. Yeah? So here we do it again. We can do it again with the other ones. We can do it again with the other ones. You have a magnetic abacus so it can stem up. No, I don't have a magnetic. This one is not magnetic. It just happens to be a little stiffer. And this is the teacher's abacus. So the teacher's abacus will stay up. And this is the reason why. So then you can have it across the classroom, right? So these are like etch a sketch. You tilt it and it will erase. No, no, no. It's more delicate than an etch a sketch. It's more delicate because if you bump it, right, or if you flick too hard, your answer is going to be wrong. Yeah. So it's almost, can you add, so you add the 10 and subtract the 2? Yes, exactly. And so what we did is we were adding the 9 and we noticed that on our abacus, we don't have enough beads to add the 9. So what do we do? I'm sorry, to add the 8. So what we need to do to add the 8 is plus the 10 minus the 2. So what we're doing is we're doing basic adding and subtracting. But we need to understand this so then we can actually become more we can come be scalable. So here is another one. Here is another one. Another question. Here's another question. Because the questions can get big, right? So if the questions get big, abacus only deals with 0 to 9. Yeah, well, all numbers is 0 to 9. We're doing decimal, right? So here, my question is 1,000. Oh, what is that? 8, 7, 5, 3, 13. 1,300. 13,000. 13,578, right? And what are we going to do? Well, we got to add all of this, but it's easy on the abacus. Why? Because now we just look at the numbers. Can we add the 2? Yes, we can add the 2. Here, can we add the 4? How do we add the 4? Do we know how to add the 4? We remember how to add the 4? We added the 4 plus the 5 minus the 1. So we plus the 5, take away the 1. Yes, thank you, Apple user. Now the question is can I add 3? Yes, all I do, add the 3, add the 1, and then add my final 1. So my final answer is 37,889. Right? So now, thank you, Apple user, now it becomes scalable. So what did we just do? That's the secret. That's the secret. The secret is if you know how to add a 5 and you know how to make a 10, where is it? This is everything that you need to do. This is everything you need to know. That's it. Now it just figures out how do you Tetris everything. Does that make sense? We can go more. So here's another question, right? I had a parent that'd be like, "Oh, isn't 8 plus 5 the same as 5 plus 8?" I was like, "Yeah, no." I feel like this is why people can't do basic math more quickly. Yeah, I mean, if we understood this, I mean, school teaches us many, many different ways of adding and subtracting. There's a lot of strategies. There's a lot of different strategies. There's a bunch of strategies. I remember seeing this one teacher. We had this one. It was a question. Where is it? It was a question like 300. It was like 300. No, 30 34 plus 14. Let's do that, right? So what did they do? They did number bonds, and I was like, okay, well, they broke it up 30, and then they did 4. Okay, fine, and then they did 10, and they did 4. Oh, okay. And then what happens? What is the fastest you can use the abacus? What is the fastest you can use the abacus? Adding, subtracting, multiplication, division. And then what happened was is they added this, that becomes 40, and then they added this, and it becomes 8, and then they added this together, and it becomes 48. That was one strategy that a teacher that I saw did. And I'm like, that's really long. If I did it on the abacus, 34 plus 30 plus 4. So plus the 10, right? And then plus the 4. How do I add the 4? We know how to add the 4. How do we add the 4? Plus the 4 is what? Plus 4 is equal to plus 5 minus 1. So I plus the 5, take away the 1. My final answer is 48. Thank you, Mackie. Does that make sense? Thank you. I just see a dandelion, right? Does that make sense? Yeah, right? It's easy. So, I mean, when you know that, when you understand it, thank you, Trip. When you understand it, I mean, this is easy too, but the difference between this and this, I don't need to do it on, I don't need to write it out. We can do more examples. So if we did multiplication, are we ready for multiplication? So we understand how to make a 10. Are we okay? So we can go further. Great. Thank you, Trip. Thank you, Oopsie. Okay, are we ready to do some multiplication? Or do we want to continue on doing adding? Because we could do that too. Yeah? Multiplication? Okay. So multiplication, abacus is doing it differently. What we do is we call this thing called what? Distributive property. So in abacus we call it distributive property. No, algebra. Distributive property. I think the human calculators have confirmed they picture an abacus in their head. Yes, you're absolutely right. They can picture this in their head. You're absolutely right. So if I had, I don't know, 24 times that by 8. Let's see that. So what's going to happen is, back to here. In the abacus world, what we do is we count our digits. We're going to count because we need to understand where we're going to put our numbers. Where are we going to put our answer? So we count 1, 2, 3. 1, 2, 3. I'm going to put my answer here somewhere. Right around here. Right around the hundreds area. So when I do 8 times 2, right? 8 times 2 is 16. Add my 1, I add my 6. Now, difference is what? In mainstream math, in new math, what do? They do this, right? This is the distributive property. They do this, but the problem is they write it out. So instead of doing 802, they say 820. So then I have 160. But on the abacus, I don't need to do that. On the abacus, it says 160. I know that this is my ones, my tens, my hundreds. So when I look, I don't need to worry my brain for the extra information. Ooh, that's not right. Does that make sense? So what we're doing is we're noticing that the abacus helps us take place, right? We have 160. Makes sense? Hello, Dolce. Welcome back. So what's next? After this, we're going to do 8 times 4. 8 times 4 is what's 8 times 4? What's 8 times 4? 8 times 4 what? 32? So I add my 30. I missed you too. 30 and then 2. So what is my final answer? Oh, Dolce, just so you know, next week I'll be out. I need to let everybody know I'll be out next week. I'll be at science camp. So does that make sense? So my final answer is what? My final answer is 192. Yes, thank you, Mackie. Does that make sense? Yes, it is 192. Absolutely. Had to mentally prepare. Yeah. Yeah, I'll be leaving, so I won't be here Monday, Tuesday, Wednesday, Thursday, or maybe Friday, but I'm not sure how tired I will be. So, so just so you know, I don't know if Melinda's still around. So, what's my answer? My answer is 192. Does that make sense? So, what we're trying to do is the abacus shows it for you. The abacus helps the abacus helps you track your numbers. The queen always needs to take a break. I will be I will be in science camp with 100 other sixth graders. So I'm not sure if that's a break. Okay, so how are we doing? Does that make sense? We can do another one. Are we ready for another one? Is there is there any way to show single digit multiplication on the abacus without doing mental math? To do that, we would have to do added at cumulative addition. So we do excuse me, 9 plus 9 plus 9 plus 9. That is what we'd have to do, if that makes sense. We would have to show the how to do 9 plus 9. So we know that 9, we add another 9. Excuse me. Yeah, that would be the only way. So when we add a 9, it is equal to plus the 10 minus 1. So plus the 10 minus 1 becomes 18. We add another one, plus the 10 minus 1, plus the 10 minus the 1. Now we have 27, right? 27. And then plus the 10 minus the 1 again, right? Plus the 10 minus the 1, we get 36. So you would have to be cumulative. And the way I would teach it is whatever the child knows what their number is, then you can add and subtract from it, right? So if you remember like 5 plus 5, 5 times 5 is equal to 25, right? And I wanted to do 5 times 6. Let's say I don't remember what 5 times 6 is. I know all I need to do is add a 5. And I think the concept of doing cumulative addition kind of is not. I think at making it cumulative addition, it makes it more number fluent for the child, if that makes sense. Because sometimes, because when I was a kid, I was taught to memorize, but we never did it this way. Like we gravitate to certain numbers, right? We gravitate to certain math facts. So if you know how to, if you already gravitate to it, we just add to it. You know what they talk about with that? What do you call it? Habits, addition habits or whatever. Like if you need to floss, if you need to floss your teeth, the first thing you do, you brush your teeth, then you floss your like adding, right? Adding habits. I always did 9 times table with my fingers. Anyone else? Oh yeah, I actually never learned that. I learned doing the 9 times table with my fingers through a movie, Stand and Deliver, and I'm like, that's brilliant. But I never learned it that way. I had to I memorized it. We were never taught that way. But I'm also very old. We were taught to memorize, so I had to memorize like 6 times 6, the 6 times tables, and so forth. But in abacus world, we don't need to know anything higher than 9 because after that it becomes redundant. Because if you notice, like even after the 10, right? So if we did, I don't know, 13 times that by 8, we'll do that, right? 13 times that by 8. Again, 1, 2, 3, 1, 2, 3. 8 times 1 is 8. 8 times 1 is equal to 8. 8 is a single digit, so I have to go back one column. So I go over here. I add my 8. 8 times 3 is 24. I add 2 and then I add 4. I add 2, right? To add 2, what do I do? Plus the 10 minus the 8 and then I add the 4. So my final answer is 104. Show them 9 on fingers, please. What? Oh. So if I don't know if I can do it. Yeah. So if it's 1 times 1 is 9, 1 times 2 is 18. Wait, let me do it the other way. There we go. Right? 1 and then 8. 1 times 8 times 9 is 27. 9 times 3 is 36. No. 9 times 4 is 36. Because 4. 1, 2, 3, 4. 5. If this is 5. 9 times 5 is 45. 9 times 6 is 54. 9 times 7 is 63. 7. 1, 2, 3, 4, 5, 6, 7. That's 7. This is 8. 72. 8 times 9. This is 9, right? 81, right? You never learned the finger method? Oh, I learned. Okay. I learned it through a movie. I don't know if anybody's watched Stand and Deliver with what's his name? Yeah, I learned it from Stand and Deliver. And I was like, yeah. Yeah. So hopefully that makes sense. So if I did 1, right? This is 1. This is 9. Yeah. Yeah. Great. No, thank you. I just yeah, we taught somebody. Yeah, I thought it was common knowledge. Yeah. It's interesting how it works. But yeah. So, yeah, it's a really good it's a really good method. Cool. Thank you for reminding me. But yeah, that's what we do. So in Abacus World, we count the numbers and we're done. Any other questions? How are we doing? Make sense? So when like what's it for? Usually, yeah, usually for small kids. I'm trying to get to the younger kids, like so that's why I've been building out some of the worksheets and stuff. So I have like some preschool worksheets workbook, and again, it's available either in my shop or this one. If you're a teacher, I'm trying to build out my other one. Again, my name is Lynette. Spin says, "Isn't that for math?" It is for math. It is a counting tool. This is a counting tool. Exactly right. This is a counting tool and it helps us track our numbers. And that's what it is. It tracks our numbers. It doesn't help us count, it helps us track our numbers. So the biggest thing is, Miguel, yes, let's do a review. Let's do a review. So when we read it, this is my abacus. When we read it, we count 1, 2, 3, 4, and then we have 5. The top beat will always be 5. Thank you for the hearts. Because this is 5, now we can do 6. How do we do 6? Because we know this is 1, and we add the 5, now we have 6. When I have 2, and I add the 5, now I have 7. If I have 3, and I add 5, because the 5 will always be the top beat no matter what, now I have 8. When I do 4, and I add the 5, I have 9. Thank you for the follow. Well, what's after 9? After 9 is 10. But wait a minute, that's 1. That's not 1, that's 10. Just as how this is 1, right? Why is that? Why? 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 Because every column is a place value. Every column is a place value. 1, 10, 100, 1,000, 10,000. How do you do a math problem with it? Thank you, Spider-Man. Does that make sense? So before we do a math problem, let's understand how to read the abacus. Does that make sense, Spin? Thank you. Miguel, are you all right? I don't know if Miguel's still around. So what we're trying to do is understand how to read the abacus. So if this is 9, this is 9, 9, 9, 9. These are all 9s. This is 9, that's 9. So now what this means is 99,999.99. I'm here. My dog is an attention hog. Ha! Okay. So does that make sense? So this, what I just did is all about 9s. So if I did this, that's 5, 5, 5, 5, 5. But be careful and not to flick too hard, because if you flick too hard, then your answers are messed up. So don't be like Zeus and Thor and flick too hard, right? What we're doing is we're understanding how to read the abacus. When we understand how to read the abacus, we can start doing adding and subtracting. So now we know how to read. When we know how to read, what number do we do is this. So if I did this, right? we can learn how to do a 2-digit puzzle. So this is my maze, and what we're doing is we're understanding how to read the abacus. So when I do this, there we go. So what number do we think this is? If I show you on my abacus, right? I have this and I have that. Please put in the chat what number you think that is. 61. Yeah. Thank you. Thank you, Dolce. Thank you, Neon. Yes, thank you, Miguel. Yes, good. So we're going to keep going and we go to 61. After 61, we got to go over here, right? And then we read that number. What number is that? So we have, right, this one and that one. 39. Thank you, Neon. Yes, thank you. Thank you, Jennifer. Thank you, Dolce. Thank you, Miguel. Right? Oh, and K Selman. All right. Cool. Make sense? So the first thing we're doing is we're understanding how to read the abacus. After we learn how to read the abacus, then we could do some adding and subtracting. Okay, so that's kind of easy, right? So we're done with that. So then the next thing, I mean, we could do we could do 3 digits, but that's okay, right? We don't need to do 3 digits. We understand it. So the first thing we're going to do, the next thing we're going to do is understand how to move the beads. When we move the beads is what? What does that mean? Well, we're going to move the beads. We need to know how to move the beads. Why? Because in abacus world, what we do is we learn and we understand how to add the add in. We don't focus on the result. This is not about the result. It is all about the journey. Just like abacus is life. Abacus is life. Life is abacus. Abacus, I got to figure that one out. So what I'm trying to say is we want to, what is it? We want to divorce the result and marry the process. It's all about the journey. We always want to know what we're adding. So when we look at it, we're looking at how do we add the one? Why are we trying to add the one? To add the one is understanding what number we're trying to move. So here's my question. My question is adding the 5. I add my 5. Math is abacus. So my question is to add the 1. Can we add the 1? So we can add 1. That's what I'm going to do is I'm going to add the 1. When we go to the horizontal bar, we're adding the 1. When I go away from the horizontal bar, then we're subtracting the 1. So what we're doing is we're understanding how to move the beads. We want to add the 1 or we want to subtract the 1. If I had 6 and I want to add the 1, right? It doesn't matter what the color is. What matters is what the beads are. So if I change it out to this one, and I have 7, I want to add 1. I'm going to add 1 bead. That's all I'm doing is I'm adding 1 bead. When I add 2, I'm only going to add the 2 beads. So my final answer is 9. When we look, again, we're looking at the add-in. So here is the other question would be 4. 4 doesn't have a lot of questions for simple, right? Can you become my math teacher? So 4 doesn't have a lot of questions. The only thing you can do is there's a 5 and you add 4. Is there enough beads to add the 4? Yes, there is. So I'm just going to add the 4. When I remove the 4, when I take away the 4, I just need to take it away from the horizontal bar. And now we're going to do it again for the -2. So I have 3. Easy. 3. Now what I want to do is I want to take away the 2. Again, take away the 2 is these 2 beads. I want to take away the 2. So why have colors if the colors mean the same thing? Because it's pretty. That's all it is. It's just pretty. I've been dealing with this for the past, just for the look. Yeah, it's because it's pretty. Because colors are fun. That's just to say that. I could say move the brown bead, but it wouldn't help this situation now, would it? It's just easier. Oh yeah, really. The colors looks yeah, more appealing. That's the only reason. I know. You know what though? I'm. It's a lot of people get hung up on the question on the colors, and I understand that. I just making fun. That's all I'm doing. I'm just making fun. Because the question would be like, well, let me label it. It's like, no, you can't label it because the reason why is the values of 1 So if I want to do minus the 1, I can take away 1, right? But then the other one is if I had 3, can I take away 1? I don't want to take away 1. I don't want to do that, right? So that's why I go back and forth between the two columns, because sometimes people get confused with the numbers. So you shouldn't label this as 1, 2, 3. That doesn't work, because if I have minus the 1, I can minus the 1 here, or I can minus the 1 here. What we're doing is we're only moving the one bead. So that's why it's very different than what we're doing in mainstream math. Mainstream math, you get 2, you take away the 2. However, it depends on where the 2 is. So if I have four, I'm going to take away 2 beads. Only going to take away these 2 beads. It doesn't matter which 2 beads. It just matters that you take away 2 beads. Does that make sense? So when I have 3, again, these are the 2 beads. I'm going to take away 2. That's why we want to learn how to move the abacus. So we don't want to label this is 2 and this is 4. We don't want to do that. We want to do is you understand these are the 2 beads that we're moving. Make sense? So again, we have 3. If I have 4 and I take away 3, I'm moving 3 beads, right? If I have 5, right? If I have 9 and I'm going to minus the 5, I remove it away. So now I'm left with 4. So what I'm doing is I'm showing you in the abacus world, what we're doing is we're focusing on the add-in, not the result. It's always about the add-in. Why? Because that's why we start getting into understanding the formulas. The top being 5 is what I thought when it went to, oh, yeah, yeah, no. This is the value. The 5 is always the value of every bead has a value. Just, you know what? It's just like money, right? It's just like the money. When we have it, right? It's like this. This is 1, this is 2, but this is not 2, right? This is not, I wish they teach this in school. Yeah, right? Does that make sense? Wanderer. Hey, Wanderer, welcome back. Yes, the 5 is the top bead is a blue bead. Yes. The top bead is the blue bead. So Jennifer, did that make sense? So kind of think of it like this, right? Every penny for itself. Just like this, every bead for itself. Yeah. Okay, good. Okay, good. Yeah. Some people do get hung up. There was a couple of people that did get hung up that this would be 1, 2, 3, 4. Yeah, I could see that. And I was trying to figure it out, but I think what it was is I think this is a better analogy because you don't call this as 1, 2, 3, 4. We just know that this is 4. Right. I think that's a better analogy. Oh, okay. So again, we want to add the 6. When I add the 6, again, what I'm doing is I'm going to add the 1 and I add 6. 6 is 1 bead on top and 1 bead on the bottom. I'm going to add the 6 like this. If I want to take away 7, I want to move it away like that. So I'm adding 7 or I take away the 7. What I'm looking at is I'm looking at the beads specifically. So when we do it, right, I want to minus the 6. I'm going to take away the 6 like that. So my final answer is 1. So, for those of you that just joined, we're going to do a little review. What we're doing is we're understanding how to move the beads. Let's learn how to read the abacus. So, when we count, we do 1, 2, 3, 4. This is 4. Anytime the beads are touching this horizontal bar, it's being counted. Whoa. So, we have 4, then the top bead is 5. 5, 6, 7, 8, and then 9. After 9, we have 10. Just as how we write 10. When we write 10, we have our ones and our tens, right? Ones, tens, hundred, thousands, 10,000. And then if you notice, our decimal sits between the ones and the tenths, and then we have our tenths and our hundredths. How are we doing? Anybody have any questions? Does that make sense? Yeah. But abacus only does arithmetic. It only does adding, subtracting, multiplication, and division. That's the only thing it does. Because why? Because it only helps us track our numbers. It doesn't do any of the thinking. How do you know how many decimal places? It depends on where your ones is. So if you choose like a Pokemon, right? If you choose your ones here, then you have 2 decimal places. If you choose your ones over here, then I'm going to move everything over, and then this will be your decimal place. So then I'd have my tenths, hundreds, thousands, million, thousands, 10,000s, 100,000s, and then millions. So depending on what this is, right? Depending on what this is, it depends on where your ones is. It all depends on what you indicate as your ones place. So if I had the bigger one, right? Like I like where you put it. Yeah. So like this one, right? If I choose this to be my ones, then I'd move everything over like that. And then I'd have all of these to be my decimal places. If I choose my ones over here or over here, then all of this would be my ones place. Yes, exactly. So here, I choose my ones. There's no decimal places here. So what does that mean? I have my ones, my thousands, my millions, my billions, and my trillions. Oh, sorry, my trillions. So looking at the way the numbers are, right? It all depends on how big your number gets. Hey, TNG, welcome back. Thank you for liking the live. Oopsie, do you have any question? I now comfortably say I understand the abacus. Yeah, that's a good what's a good addition problem to practice an abacus? Two-step equation. So we didn't actually do a two-step equation, but that's a really good one. A two-step equation is interesting because it combines the everything that we learned. It combines what we learn how to do a 5 and it combines how we do a 10. Let's do a two-step equation. One of the question was 7 plus 7, and I kind of didn't want to do it until we were comfortable enough to understand how to do adding of the 5. So the first question is 7 plus 7. That's easy. We've memorized what 7 plus 7 is. But to show it on the abacus, it's a little different. So what does that mean? There's a two-step equation, meaning that we're Tetrising our way through how to add and subtract. So what we're going to do is we're going to have 7. When we have 7, I want to add another 7. How do we add another 7? Do we know the formula to add a 7? Do we remember what the formula was to add a 7? Right? Do we know? It's the plus 10. Exactly. Plus 10. Plus the 10, right? Minus the 3. Yes, thank you. Thank you, Jennifer. So what we're going to do is when we add the 7, I want to plus the 10 minus the 3. When I plus the 10, I want to take away the 3. However, I cannot take away the 3. This is why it's a two-step equation. This is a two-step equation. Why? Because I no longer have anything to minus the 3. Do we remember how to minus the 3? Remember how to minus the 3. I briefly touched it. If we know how to add, we know how to subtract. If we know how to add, we know how to subtract, because now we start talking about number patterns. So if I want to minus the 3, and remember 3 and 2 are partners. So if I want to minus the 3, we know if we minus the 3, we're going to have to take away the 5 plus the 2. So what does that look like? I'm going to take away the 5, and I'm going to add the 2. So my final answer is 14. What did I just do? Well, if you notice, when I add the 3, it's plus the 5 minus the 2. Now we have a number pattern. Plus the 5 minus the 2. Minus the 2, plus the 5 minus the 2. Or the opposite, which is minus the 5 plus the 2. So we know if we want to add the 3, if we want to add the 3, it is plus 3 is equal to plus the 5 minus 2. If I want to take away the 3, then I'm going to minus the 5 plus the 2. Does that make sense? So what did I just do is I just did what they call cumulative property. There's only 4 beads, so you could split them evenly. Yes. Yes. So this is why it's critical to understand how to do adding and subtracting, how to make a 5, how to make a 10. So we know how to make, and then don't notice it's kind of the similar, right? They're kind of the same, but just opposite operation, right? Thank you for the follow, Trip. So here, notice we plus the 3, we can minus the 3. We can plus the 2, we know how to minus the 2. It is not a separate strategy to take away, which is really interesting. What we do is we compound our math knowledge, the inverse. Thank you. The inverse. I gotta add that. I gotta add that to my repertoire, right? So what we did, right? What we did, notice 10 has the same thing, right? We can add the 10. I'm sorry, the adding of the 9 or minusing of the 9. Same thing. And that's what it is. Okay, so here's another one, right? Here's another two-step equation. Oh, so my answer is 14. Here's another two-step equation. Oh, that's why, yeah, we can do this one. 49 plus 5. We'll do 5. That's another two-step equation. Why? Because when we look at it, we have 49. Add 4, add 9. Do we remember how to add the 5? I'm going to hit like until you get an answer with an 8 in the ones place. Okay? I'm not sure what that means. An 8 in the ones place. Before I do that, bring down the 5. No. See, the 5, when we add the 5, what are we going to do? When we add the 5, this is a formula, right? There is no plus 5. Where is it? There is no plus 5, right? There's only add the 4, add the 2, add the 3, add the 4, right? There is no 5. Does that make sense? So when we look at it, this is a plus 10 formula. This is a plus 10 formula, right? So when we do a plus 10 formula, plus 5 is equal to what? We have our plus 10 formula. Plus the 5 is equal to plus the 10 minus the 5. So we're going to do plus the 10 minus the 5. Let's minus the 5 first, and we're going to plus the 10. Oh, look, we cannot plus the 10. Yeah, we can't plus the 10. What are we going to do? What are we going to do? We're going to plus the 10. How do we plus the 1? So this is why, what? This is why adding and subtracting, adding the 5. Because what are we trying to do? We don't have enough beads to add the 4, right? Right? Exactly. Exactly. So we add the 5 and we take away the 1. Oh, sorry. Take away the 4. So my final answer is 54. So what we just did is we combined the two and now it's scalable. Everything you see here, what I just told you about how to add a 5 and how to make a 10, those are all scale. Now it becomes scalable and it doesn't matter what number it is. Oh, okay. So yeah, Pancho, thank you. So here is 43. Is there enough to add the 5? All it is this. Add the 5. Can you do 3 example problems slowly, maybe minimal commentary? I can try. Thank you, Eve. Hi, Eve. Yes. So let's count on the abacus. We can do 1, 2, 3, 4, and then we have 5. The top bead that touches the horizontal bar is counted. So this is 5. We have 6. How do we know that this is 6? If you notice, we have 1 plus 5 is 6. If we have 2 plus 5, what number is that? Thank you, Jennifer. Yes. Why do I start here? Thank you, Trip. The reason why I start here is because I have a ones place. I have a ones indicator. So my ones indicator, I chose this one. So then I have every column is a place value. If I choose this one to be my ones, then I'd move everything over. So I'd have, yes, thank you. Thank you, Pancho. So yes, all of this would be my decimals. It'd be 0.007, right? So there's my decimals. If I choose this one to be my ones, then I have two decimals, just as Pancho said. Hey, Ouija, you can choose your starting point. You can make it decimals. Yes, exactly. Exactly. Okay. Oh, yes, we're still counting. So if I do 3 and I add the 1, add the 5, what number is that? So we just did it. 3 plus 5 is 9. We need this to be in schools. Ah, thank you. Thank you, Trip. Yes. 8. I'm sorry. Yes, thank you. 8. 3, 1, 2, 3 plus 5 is 8. Thank you. 4, 1, 2, 3, 4 plus 5 is now 9. Thank you, guys. Thank you for your help. So what we're doing is we're learning how to read the abacus. When we understand how to read the abacus, then we can go into, I like this condensed version. Yeah. It's a lot easier to handle than the blocks, right? Because now we can do place values. Then we do this. This is 10, right? 10, 11. But if you look, 10, 20, 30, 40, 50, 60, 70, 80, 90. And then we do 100, right? Now we have place values. When we look at the place values, we can do this, right? 192. Yeah, no, thank you for your help, Pancho. Thank you. I appreciate that. No, I appreciate all the help that I can get. Because I forget where I am in my commentary. So sometimes, and thank you, Eve, for letting me reminding me of counting. Because there's a lot of people that come in and I forget that they don't start from the beginning of my live. So what we're doing is we're learning how to count, right? We're learning how to read the abacus. And so one of our questions was what? How to add minimal. So if I had 7 plus 2, ooh, right? 7. Yes, my kiddo needed the counting demo. They can get better now. Oh, good. Oh, good, Eve. This is 7. Is there enough to add the 2? So we add the 2. Yes, thank you, Trip. Yep, thank you, Jennifer. So my answer is 9, right? Because what is the question? The question is always going to be, is there enough? Is there enough beads? So we have enough beads, we can do it. If there's not enough, then you can start using the formulas, right? Then we can modify it to a point where, and then if you know how to Tetris everything, so another question would be for Trip. If you wanted to do another two-step, oh, you know what would be another good one? Another two-step good one would be 999 plus 9. Is that too many nines? This would be a good one too, right? I mean, it's we know what this is in our head. We know, right? Add the 1 and then we have 108. We know this. But if you want to show it on the abacus, right? 999. The reason why it's to show it on the abacus, it makes it makes more sense because then it become versatile. But the reason why we do this is to practice the two step. There's many ways to add, right? There's many ways. But what I'm just showing you is how to do it on the abacus. So here we know what when we want to add 9, we're adding 9. What is plus 9? Plus 9 is equal to minus the 1 plus the 10. So I'm going to minus the 9, minus the 1, and I want to plus the 10. Yes, thank you. So now I want to plus the 10. I cannot plus the 10. What do I do? What do I do? If I cannot plus the 10, what do I do? Plus 1 is equal to minus the 9 plus the 10. So I'm going to minus the 9 and I'm going to plus the 10. I can't do it. I cannot plus the 10 here. I cannot add the 1. How do I do it? So I do it again. Minus the 9 plus the 1. Can I do it? Yeah, I could do it. So my final answer is 1008. 1008. So what did we just do? We did two steps. This is one step. This is the other step. Yep. And we just keep doing it until we can't do it anymore. Right? But if you notice, it's only two equations. But again, those two equations needs to be something that you need to remember. This is something that you have to memorize. These are the only things that you need to memorize. Yeah. Thank you, Jennifer. Oh, good. Oh, good. I mean, you could teach the kids add the one, right? But we're doing it abstract. When we do it abstract, it's difficult for the kids to understand. The mechanics makes it so much sense after you explain it just now. Yes, yes, exactly. It's the mechanics of understanding the numbers. Because when we do this, we are not teaching the kids the we're not teaching the kids the amount, right? I can't see this in my head, but I can see it here with the abacus. Is it a must? It's not a must. It's just another way of learning. And that was one of the things. Thank you, Pancho. So I mean these are simple ripple effect in each tenth place. Yes, yes, exactly. Because what do we do in school, right? We do the same thing. 18 carry the one, and then this is 10 carry the one. So what we just did is carrying the one. Thank you. It is the ripple effect. I'm going to start using these words. Yeah. So, and it's interesting because you can see it now. You understand, oh, I can't do it. I got to keep going until I can. And it goes back to having a conversation with your questions, right? Instead of going into memorizing certain ways, carry over until you can't do it. Exactly. Carry it over until you can't do it anymore. Doing this doesn't tell me that I can stop. Doing this tells me I can stop, if that makes sense. Thinking in portals. Yeah, I could see that, right? Keep going until you can't do it anymore, right? We could do the same thing opposite, and that's that's the interesting thing about it, right? You do it the same way with subtraction. There's no difference. If you do it one way, you could do it the other way. It's just, reversing it. So it's really interesting because in school we're teaching one way to add and another way to subtract. Whereas in abacus, we teach you one way to add, it's just like waxing on and waxing off. When you wax on, it's the same way as waxing off. It's just opposite, inverse, which is very interesting. Whereas I don't know how they, can you do another one? Yeah, 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 yeah. Um, uh, oh, you know what? We'll do minus. Wait, before we do that. Yes, chiral? I don't know what chiral is. Oh, there we go. Yeah, we could do that. I was going to do, okay, 889 minus 9. So when we do it, oh, minus the 9, 008, right? So what are we trying to do? We're trying to take away the 9. Right? So what do I do this? I do it because it gets a little overwhelming to see how many columns are. It gets a little overwhelming. So that's why I do this. I have my kid, when he was going through it, he was like, "That's too many columns." I'm like, "Okay, that's fine. Let's just focus on the one." When we focus on the one, what are you trying to do? We're trying to minus the 9. Minus the 9 is equal to plus the 1 minus the 10. That's what we're trying to do. We're going to plus the 1. And then what? We need to minus the 10. I can't minus the 10. Minus 1 is equal to plus 9 minus 10. Add the 9 minus the 10. Carry over. Carry over or borrowing, right? Or borrowing. Can't minus the 9. Cannot minus the 10. There cannot take away the 1. Do it again. Add the 9 minus the 10. Can you take away the 10? Yes. I'm going to take away the 1. So my final answer is 999. Yeah. 999. But we just did the reverse. So those were the two, right? We did one way and then we did the other way. Thallium, thulium, and thallium. Yep, right. But if you know one way, you know how to do it the other way. Again, it's a balancing, right? Oh yeah, yeah. It's I find it interesting because this is awesome. Thank you for sharing. Yeah, not a problem, Jennifer. I enjoy talking about abacus and how because I'm because what I'm trying to show when the numbers get bigger, it's easier to decompose. It's easier to make it into smaller things, right? And it gets better when we start doing multiplication and division. Because in multiplication and division, that's where it really shines. The reason why is because we break it down into smaller chunks. We don't do the big division questions. We actually break it down into smaller chunks, but we can do that in a later time. So, but like for right now, understanding how to add and subtract is the key, right? And then it solidifies and it fills the gap. And abacus is the gateway to complex math. This is not the end all. You can't do calculus, right? But you understand your foundation, you understand how to move the numbers, you understand, how to add and subtract simply, right? And then compound it because then you can do big numbers, right? I mean, it's not 12 base. No, it's not a 12 base. It's a 10 base, right? So because you solidify your concept, then you can use your math knowledge for more brain power of the higher math, right? This is just to make adding and subtracting more implicit, where it becomes more natural. Like so for me, I could see that if I'm going to do 800, 1008, I know this is what I'm going to do. I'm going to do this, right? I know that because I can see it. But I'm explaining it to you guys. I need to take it a little slower. But because I know how to do this, then it becomes natural, if that makes sense. But the more you work with the abacus, the more easier it will, obviously the more easier it'll get. It's just like playing the piano, right? We know how we do CDE, right? CDE, CDE, or we do like Beethoven's like what Fifth Symphony or whatever, da 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 da, right? Or Ode to Joy, whatever, right? It's all easy. It's just it's just practicing, and the more you practice how to numbers move, the more you'll see the patterns, which is interesting because math is all about patterns and abacus really shines with the patterns. Here is what we were talking about. This is the addition table. And if you notice in the addition table, we have our simple. Our simple is the one question was, well, how do I know 2 plus 2? 2, is there enough beads to add the 2? Yes, there is. So I'm just going to add the 2. So when we look, we have our simple. That's what this is here. This is the blue or the green or whatever, right? And then after that, we have the adding of the 5. When we add the 5, this is now a pattern. And we notice that this is another pattern. This is where we add the 10. Because we add the 10 here, then this right here is our 2-step. And it just compounds, right? When we have bigger numbers, it just compounds. So this is now subtraction and it does the same pattern, right? Which is fascinating because they don't teach us that in regular math. So if I show you like a bigger number, let me show you a bigger number. So here's like making of the 20, not making of the 20, here, 60, 60, 61. So when I look, these are all simple. And again, here's the pattern: 61 adding 5, 61 adding the 6. These are the two step. This is the 10, how to make a 10, right? And these are just patterns. And it goes on and on and on. But that's the pattern. You know the pattern. You can add and subtract anything, anything. I find it fascinating. I find it so fascinating that there's all these patterns, but we don't use math to its fullest potential when we talk about patterns, right? We don't say, well, right? Which is really quite interesting. That's why if you know how to add and subtract, like really know how to add and subtract 5 and minus 10, everything under the sun will be easy. Hey, sunshine, welcome back. Does that make sense? Anybody have any questions? I mean, we can go on doing more adding and subtracting. We could do other stuff. Oh, we could do this one. Oh yeah. How this math work? More two steps. Okay, let's do two steps. But let's before we do that, let's do a review. Let's do a review on how we read the abacus. So we have 1, 2, 3, 4, and then 5. 5, 6, 7, 8, 9. After 9, we have 10. 10 is 1 and a 0. How do I know? Because I'm using this as my ones place. And so I have my ones, my tens, my hundreds, my thousands, and my 10,000. When we look, every column is a place value. Every column is a digit. Every column that, that's not touching is not counted. So this is 10, 1 and 0. 11, 12, 13, 14. Does that make sense? And then we can do 15. But see, the two step is very interesting. Why is the two step interesting? Because there is a path. Oh, good. Breeze bets. Thank you. Make sense? So another two step. Okay, we'll do 15. I'm seeing clear now. Oh, good. We're gonna continue more. I will slow down, but there's gonna be some things that we need to understand. So here is one, right? This is an easy one. One of my parents was like, "Okay, I have this. Isn't this the same as this?" No, it is not the same. Why? Because it's all about the add-in. It's all about this add-in right here. Okay? This is where we have to be careful. We know this. We know 8. We can add the 8. We're going to add 8 on the abacus. We add 8. This is 8. 5, 6, 7, 8. We know that, right? That's how fractions are structured. I'm not sure. Maybe. So here we add the 5. When we add the 5, what are we going to do? We know how to do this, right? What? I don't know. That's 11. No, it's not. Numerator always on tops can't have an improper fraction. Yeah? You need to add the plus. What? Plus. I don't know what you guys are talking about. I did add the plus. Okay. So we're going to add the 5, right? We want to add the 5. We can't add the 5. What are we going to do? We know how to add the 5. We're going to utilize this concept. This concept is plus the 5 plus the 5 plus the 10 is equal to 10. Plus 5 and 10, right? No, that's not what we're going to do. What we're going to do is we're going to modify. We are going to So we're going to take the 5, right? And what we're going to do is we're going to make it a plus 10. When we plus the 10, we got to make it, this is too much. We have to minus the 5. When we minus the 5, now we know how to utilize it on this form on the abacus. What we're going to do is we're going to plus the 10, 1 and 0. And then if you notice, we have to minus the 5. So what we're going to do is we're going to minus the 5. And my final answer is 13. Does that make sense? So that's the one way. This is how to do it with the plus 10. So is that the same? No, it's not the same. The answer is the same, but the way to get there is different. So here is the two-step, right? We have the 5. We add the 5, not a problem. We add the 5, not a problem. But then we're going to do is we're going to plus the 8. When we add the 8, what are we going to do? We cannot add the 8, right? We don't have enough beads to add the 8. To add the 8, what are we going to do? To add the 8, we know that we need to utilize our 10, right? This is where a two-step comes in, right? What's going to happen is we're going to plus the 10, we're going to plus the 8. To plus the 8, we don't have enough beads to plus the 8. 5. Not enough beads to add the 8. So what are we going to do? We need to plus the 10 minus the 2. So we're going to plus the 10, and then we need to take away the 2. Wait a minute. We don't have enough beads to take away the 2. So we have what? 8 is equal to plus the 10 minus 2. We cannot minus the 2. What's another way to minus the 2? Do we remember? Minus the 2. We know. I'm so happy to see you. And hey, Laura. I was just telling my husband about learning this. Yeah, that's funny. Yes, yes. So we're going to do is minus the 5, right? We're going to bring up the 5, bring up the 3, and minus the 5. And my final answer is 13. Yes, exactly. Thank you for the follow. So what did we just do? This is the two-step. This right here is the two-step because it's minus the 2 is equal to minus the 5 plus the 3. So what did we just do? What we did was a two-step. This and this is connected. So even though the answer is the same, it's different how you get there. We all want to be happy, but it depends on how what happy means, right? It's about divorcing the divorcing the divorce the result, right? Some conundrum tunneling there, right? Yeah, this is the portal. Right? So what are we doing? We're understanding the process to get there, right? We always look at the add-in. What are we trying to add? Is what we're trying to decipher. Portal tunneling, maybe quantum. I don't know. Those are big words. TNG. Those are very big words. How are we doing? Does that make sense? So what did we just do? What we're understanding is the difference between the two add-ins. It all depends on what we're trying to do. It doesn't matter what the result is because this is a very simple problem, not what I'm trying to do. What I'm trying to show you is when we get into bigger problems, let's see, when we get into bigger problems, then we can't see it anymore. We can't see what the number is, right? Like, what is it? Where's my numbers? I should rewrite it. Do, 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 do. Right? Like this number here. Sure, you could do it in your head, not a problem. But then when you get to bigger numbers, like, what is it? Like this one? Where is it? Oh, yeah, like this? I mean, you could do it in your head, or you could do it easily on the abacus, right? 1, 3, 5, 7, 8. And then what? Plus 2? Is there enough to plus the 2? Yes, there is. Plus the 2. Plus 4? How do you add the 4? Add the 4? How do you add the 4? To add the 4 is plus the 5 minus 1. Can you add the 3? Yes? Add the 3. Add the 1? Add 1. So my final answer is 37889. And that's the beauty. That's the beauty about learning abacus. It will tell you whether or not you can do it. And you focus on one column at a time. Don't focus on the whole thing. focus on one column. And then, so my answer is 7 of 9. uh, I love that. She was so good. 7 of 9. She was so good. Oh, that whole board. Oh my god, that was such an epic storytelling right there. And then when Picard started crying, oh my god, I loved it. That was such a great storyline, right? So yeah, 7 of 9, so good. Okay, and the Borg. Oh, I should watch that again. It's been a while. All right, so that's what it is. That's all about abacus. I mean, we could do more. We want to do some more. We can do more 2 steps. So I'm just looking through my um yeah, I made this to explain a little bit more. So here is the question, right? This is an example question. And if I had 9, right? I have 9 and I want to add the 8. So there's not enough beats to add the 8, right? So what's going to happen is here's an explanation of what the tens and the ones is on the abacus. Tens and ones. So here's the formula, and we'd isolate it. This is really cool. I never, until I watched you always do it, always thought it was beyond me. Yeah, no. No, it's simple to use. Simple to use, easy to understand. If you're open to doing something different, right? If you're open to understanding how to do it differently, right? It is a different way of thinking. Because in abacus world, we don't think about the result. We think about the add-in. We think about the procedure. Whereas in mainstream math, in elementary school, in grade, like, I know for sure in second grade, I have a teacher and saying he can't yet talk about abacus because he has to change his way of thinking, right? He has to change his way of thinking because he thinks in the result first. But in abacus, we have to think of the add-in first. Demystified for me too. Yes, thank you. So here, right, what are we trying to do? We're trying to add the 9. So this is my explanation, right? I'm trying to make it easy to understand. I want a 9 plus the 8. When I want to plus the 8, there's not enough. There's not enough to plus the 8. You notice there's not enough beats to plus the 8. So what do? I need to isolate the variable, right? Isolate the variable. I'm going to isolate the variable and equal to 10. That's not balanced. So we're going to minus the 2. Notice, right, you can rewrite it the other way. We can say 8 is equal to minus 2 plus the 10. Or we could say plus the 10 minus the 2. So here's our instructions. On the abacus, on the tens, you want to add the one bottom bead up, right? And then on the ones, you want to remove it down. So then what do? Is we take the 8, we substitute this information, and this is how we do it. So our final answer is this 7. The best part of the Mandalorian was the chrome of the Naboo fighter. Yeah. So I try to explain it through this way, through a simple yet effective question, right? So what I was trying to do is I was trying to explain how to do this. When I want to add the 8, I need to substitute this information. When I substitute it, this is how I do it on the abacus. So all we're doing is we're moving the abacus, but in your mind, in your head, you have this information. So our brain is the calculator. Um, that's why this is mental gymnastics. Like, it's comparable to Sudoku, crossword puzzles, word searches, and so forth, right? And when we do calculations in our head, we're actually doing calculations in our head. That's why it helps with, with brain function, right? Anybody have any questions? But yeah, that's what this is. Oh, and then oh, that was the thing I was going to do. So what I did is I also added, not this. This is all of the formulas you need to know when you add and subtract. So we have it where I have little labels. This is my prototype, but I have like little labels, and then towards the end I have Oh, I have the framework. So when we talk about the framework, right, we're adding, this is the abacus framework. We have 7. When we add the 7, I want to add 4. I want to add 4 here. I cannot add 4. What do I do? The question is there enough beats to add, is there enough beats to add the 4? No, there isn't. So instead of going here, because I don't have any more beats, I have to go here. No. The question now is, can I use plus 5? Yes or no? So what am I trying to do? I'm trying to add the 4. Can I add the 5? Yes or no? No, I cannot add the 5. So what do? I got to go here, plus the 10. Plus the 10. Can I plus the 10? Yes, I can. So what do? I plus the 10 because I'm trying to add the 4. Plus the 10 minus the 6. So I'm going to plus the 10 and I take away the 6. And my final answer is 11. This is the abacus framework. How did that go? Are we all right? Thank you for the follow. Did that make sense? Yeah? So we could do it again. So I have another one. Gotta do the framing. Gotta do the framing. We gotta do this one. Let's do 17, right? When we do 17, we want to take away 4. Now what do? We take away the 4. Is there enough to take away the 4? Yes or no? No. There's not enough beats to take away the 4. So we gotta go down. Can we take away the 5? Yeah, we can, right? Because what do? To minus the 4, we want to take away the 4 plus minus the 5. Minus the 5 plus the 1. Minus the 5 plus the 1. My final answer is 13. Oh, I should have done it the other way. That's what it was. Okay. Yeah? Does that make sense? Toby, let's do a little review. What's happening is we're learning how to use the abacus. We're learning math. You're voluntarily coming to my room to learn about math, just so you know. Here's how we do math. We're going to count first. 1, 2, 3, 4. Okay, this is 4. Anytime the beads are touching the horizontal bar, we're adding, this is 4. This is what's being counted. Does that make sense, Toby? So when we do 4, what's 5? 5 is up here. The 5 will always be the value of 5. The 5 is the top bead. 5, 6, 7, 8. That's 8. 5, 6, 7, 8. 5 plus 3 is 8. And then 9. 5 plus 4, 1, 2, 3, 4. Now we have 9. Toby, does that make sense? So then what do we do for 10? 10 is that. 10 is this. How do we know? Because we have our place value. Every column is a place value. We have our ones, our tens, our hundreds, our thousands, our 10,000. Ones, tens, hundred, thousands, 10,000. Yeah? We have a decimal. Sits between the ones and the tenths, just like money. So we have our 1/10ths and 100ths. I see double here. 4 Kruskies. Oh, yeah? I don't I don't see anybody. I just see anybody who's commenting. That's all. So, how are we doing? Are we all right? So we're gonna review again. We count 1, 2, 3, 4. Toby, do you understand that this is 4? Maybe? That's not a maybe. It's a yes or a no. If you don't know how to count to 4, then I don't think this is the room for you. And you can move on. If you're not trying, then there's no point of wasting my time. No, maybe in abacus. 4. That doesn't make sense to me. How do you not know that this is four? This is four. One, two, three, four. Does that make sense? No. Yes or no? What's in the box? That's what's in the box. What's in the box? Hey, Chaz, welcome back. The box. Yeah. Okay. I don't know. Okay. Toby doesn't seem like Toby's paying attention. I can't find my money. When the beads touch the bar, they're counted. Yes. Yes, exactly. So when the beads are touching, they're being counted. So none of these are counted. So these are not. You're right. Thank you. So what's going to happen is one, two, three, four. These are this, and then if I do this, this is zero. The four beads on the bar equals to four. That's correct. And so when we do one, because this bead is touching this horizontal bar, now we have one. If I do this, now the beads are touching each other. They're holding hands, and now and it's touching the horizontal bar. This is now two. When I look, this is three. How do I know that that's three? Because they're all touching each other. They're all holding hands. When they hold hands with the horizontal bar, that's being counted. So this is now four. We have, I'm sorry, four. That's enough math for today. Yeah, I think so. I think I'm getting very tired. Thank you, TNG, for joining. Yeah, I've been on for like a good while. Did you create this? No, I did not create this. I no. No, this was so how much if all the greens oh, like this? That's a good question. So when we look at it, 11,000, 111.11. That's what it would look like. And the comma is like that. That's a comma. Yes. Thank you, Ranjo. The abacus is an ancient counting tool. Yes, thank you. Thank you. I'm getting tired. I just started feeling it. So I apologize for the attitude. I apologize for the attitude. I'm just getting kind of tired. All right. So again, so going back, we have five. What does that mean? If I do all the blue beads, this is five. I'm still with you. Hey, Hicksman. So we have 5, 5, comma 555.55. That's what that means. So if all the blue beads are touching, that's what it'd be. Make sense? So now, but this all the top bead is a value of 5 no matter what. So when I look, this is 5. Yes, thank you. Yes. Now I fully understand where the frame for binary came from. Okay. I don't know. I don't know how binary works, so I cannot comment on that. Yeah, blue is 5. Yes. But Runjo, it's more like the top bead. The top bead is 5, like that. It's all about the positioning. So that's what 5 is. There's only one way to do it. 35. Yes, so Toby, 35. 30. 1, 2, 3, 30, and then 5. Right? So we can do it again. If I line it up, 30, 5. 1, 2, 3, and then 5. When I do it, when I show you, here's the tens. Is there a specific, so where is this applicable to life or is this specific to mathematics? 0 to 15 counting, so it's easier to understand if you don't mind. 0 to, oh, okay, yeah. No, thank you. I appreciate that. So when we count 0, 1, 2, 3, 4. No, I appreciate the advice. I get a little fuzzy brained after too much, you know? So this is 4. One, two, three, four, five, six, seven, eight, nine, and then we have 10. This is 10. 1 and 0. 10, 11, 12, 13, and then 14 and 15. It's like reading money. Yeah, it is like reading money. Start from the left. No, you could if you did this. Why? Because I have my indicator. This is my ones indicator. This tells me where the ones, it's like a label, right? So it's like Pokemon. You get to choose which one you want to choose. So I choose you, or I choose you, right? Or I choose one. I have to choose one to be my ones place. So when I zero it out, I'd count one, two, three, four. It'd be just like we don't start from we don't start from the left, just like when we write. So if I did 10, it would look like this. 10, 1, 0. It would be better to be suited to start from the left to leave the decimals for further lessons. Yeah. So if I did 10, 11 would look like this. 11. Everything on the right becomes decimal places. Yes. Yes. So if I did 12, it would look like that. Yeah. Decimal places, I don't usually touch decimal places until later. Toby, does that make sense now? I don't know if Toby's still around. So when we look, right, that's what it would look like. I'm trying. Okay, as long as you're trying, that makes sense. I appreciate that you're trying. If you use a larger abacus with more columns, yes. Where would I use this? Run Joe. Where would I use this? Teaching kids? That makes sense. This would be if you want to learn a different way of adding and subtracting. This would be if you want to use brain gymnastics, like if you do jigsaw puzzles, right? You know how jigsaw puzzles keep your mind active? You'd use it then. If you do Sudoku, it would be something like that. It would be more for adults, it'd be more of a hobby, right? For adults it'd be more of a hobby. Why? Because we've learned one way to add. But if we want to teach children, it'd be more beneficial to teach the children with an abacus, if that made sense. So when we look at it, how I look at it, I would do it for my own mental brain gymnastics because the way numbers are, there's a pattern. So would I use this in everyday life? No. I'm teaching you guys, so it's part of me, but is it going to be part of you? No, it wouldn't be part of you unless you are doing word searches, crossword puzzles, Sudoku. So those are all that's where it would sit, right? And that's where it would kind of lie around. It'd be like a hobby for adults. I see it used as a kid, but never learned how. Yeah. I mean, if you want to learn it, then you're here. If you start on the left, there's no way to be larger numbers. Exactly. So now we're stuck at 12, right? If I want to do 100, I can't do 100, right? I can only go up to 99. I can only go up to 99, if that makes sense. I cannot go to 100. So that's why I would start over here. I move it to here. This is my ones. One, two, three, four, five. Because this is 5. Oh, sorry, this is 9. I'm sorry, this is 9. I do 9. This is 99. Because 99, I have 100. I could do that. 100. Yeah. No, I do thank you guys for commenting because I don't know who's a spammer and who's not, right? And I don't know who is really trying and who's not trying. So it's hard to see through text. But no, thank you Toby for trying. I do appreciate you letting me know, right? I get a little bit on edge when people are like, "That makes it." I mean, we just had one person that came into the room and said, "You're making it more harder than it is." I'm like, you know what? Just move on. But that's hard. It's hard to filter out who is really genuinely wanting to learn how to use the abacus and those that don't. Right? Yeah. It's up to you if you should buy it. I do have it available. There are two sets. It's either this one for young kids. I like this one because it's nice and pretty and it's colorful. There's this one which is larger, and you can start doing multiplication, division on this one. This is a 13 column abacus. It works exactly the same. It's just bigger numbers, bigger digits. Ones, thousands, millions, billions, and trillions. So every dot can be a is a group. You could start here if you wanted to, and then you'd have thousands and millions. You could start here, and then you have more, right? So it doesn't matter where you start as long as you pick one place. Toby, are you okay? Let's do a routine problem. Are we ready for that? I wish I would learn this as a kid. Trip. Oh, Trip, you're still here. All right. All right. Yeah, I'm starting to feel a little bit tired. I will be ending the lives pretty soon. All right. Routine. Okay. Okay. The first thing we're going to do is understand how to move the beads. And this is different. Excuse me. This is different in abacus world because what we need to do is we need to understand that we're going to be doing the add-in. Before you go, can you do a simple times table on it? Yeah, I can do that. Yeah, not a problem. Okay, so there's a few phases to go through, Joe and Toby, are you still around? So, and X-Men, thank you. What's going to happen is we focus on the add-in. These are I know these are simple questions, right? But if I make it too difficult, then you'd get lost in the numbers. So this is why we focus on the simple problems, right? It's just like understanding the basics. You wax on, you wax off, right? If anybody's watched Karate Kid, you put the jacket on, you take the jacket off. It's very simple, but we need to understand the basics before we can go into bigger numbers, if that makes sense. Is that all right? So that's the caveat. Understand that we need to know the basics. So the first thing we're going to do is we're going to understand that when I add the five, I'm going to add the five. That's what the question is. Add the five. I want to figure out my add-in. My add-in is to add the one. Is there enough to add the one? Is there enough to add the one? Yes. So we're going to add the one. The new Karate Kid or the old Karate Kid with Ralph Macchio? Right. Thank you, X Men. Does that make sense? So I know it's simple. I know it's simple, but we need to understand is how to move the beads. So here we have eight, the old one. Oh yeah, with Ralph Macchio and Pat. So we have eight. We have eight. We want to add the one. When we add the one, again, what we're going to do is we're going to move only the one bead. Does that make sense? So that's the one thing. The next thing is two. Two is easy. Two is the same. Two, all we need to do is figure out, do we have enough beads to add the two? So if I have six, I want to add two, I'm going to add these two beads. That's all I'm doing. I'm adding these two beads, right? Now I have eight. How do I know that that's eight? Because the beads are touching the horizontal bar, it's being counted. We have five, six, seven, eight. That's eight. If we add one, this is now nine. We take away one. Notice when I take away the one, I'm moving it away from the horizontal bar. So if you notice, I have eight. I want to take away one. As easy as we move, yeah, thank you. Okay, good. As easy as we add, we can subtract. Notice it is a pattern, right? The pattern is when we add, we can subtract. When we add, we can subtract. So we're adding one and take away the one. Okay, so now we can do, okay, we did the minus one. We did the three. We can do the three. The three is the same, right? Is there enough to add the three? Have I have five? Do I have enough to add the three? Yes, I do. I'm just going to add the three. So that's about the basics of moving, right? We can do the, and we already talked about the minus, and after the minus, we can do the fives. Would the blue bead ever? No, no, Joe. It would always be five, no matter what. No matter what. All of this is five, right? It's like a nickel, right? Does a nickel ever change its value? Where's my nickels? Right? Does the 5 cents ever change its value? No, it's always going to be a 5 cents. It will always be a 5 cents no matter what. It will always be a 5 cents no matter what. Can you change that? No, you can't change that. That's the value. You can't change the value. Yeah. So here I'm going to add the five. Oh, what am I doing? Three. I have 3. I'm going to add 3. Add 3. When I add 5, right? What's my answer? My answer is 8. I like the money thing. I think the money is a really good prop. So when we do 8, right? It's the same thing with the 6. 6, I have 1, and to add the 6, it will be 5, 6, and I bring it together. When I take away 6, I just move it away. So if I have 3 and I add the 6, remember, 1 bead on top, 1 bead on the bottom, and we add 6. How do we get 10? 10 looks like this. 1, 0, just the way you wrote it. 0, 1, 10, because every column is a place value. This is the ones, this is the tens. Ones and tens. So we can count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90. Great, thank you, X-Men. 100, 200, 300, 400, 500, 600, 700, 800, 900. Okay. So the next thing is to do is what happens when there's not enough beads. That's the next question, right? The next question is what happens when there's not enough beads? What? When does that ever happen? Screen left inventory. Oh, I don't know. So what's going to happen? When I have 4, the question is 4. The question is 4. When we have 4, right? This is what we're doing. Why are we adding the 4? We're adding the 4 because we don't have enough beads. And this is how we do it. Where? Oh, ah, thank you. Thank you. I appreciate that. We have 2. I want to add the 4. Notice there's not enough beads to add the 4. Well, then what do we do? I don't know what to do. What are we doing? Well, we have this concept that we're teaching the children. We're having the concept to teach the children how to make a 5. But in Abacus World, we actually modified this. We do. So what does that mean? If I want to add the 4, I have this concept. What we do is we're going to modify this. We're going to isolate the variable. Why are we isolating the variable? Because I want to add the 4. To add the 4, I don't have enough beads to add the 4. I don't have enough beads to add the 4. What do? I need to utilize this concept. This is a concept we're going to take. When we take this concept and we modify, we're going to isolate the variable, right? To isolate the variable, what are we going to do? We're going to make 4 equal to 5. When we make 4 equal to 5, that's not balanced. That is nowhere left balanced. What's going to happen? We need to balance the equation. Now we have a balanced equation. We can substitute this information into the 4. Why are we going to do that? Thank you, Trip. The reason why we're going to do that is to utilize the abacus. And it's giving you directions. Now you don't need to memorize your doubles. What you need to memorize is this concept. Plus the 5, take away the 1, gives me 6. Thank you, Trip. So we can do it again. What? Becomes more versatile, right? Now what we're doing is we're adding versatility. So we have the 3. There's not enough to add the 4. What do? I know to add the 5, take away the 1. My final answer is 7. We can do it again. We have 4. I know what 4 plus 4 is. Yes, we've all memorized what 4 plus 4 is. But 4 plus 4 is very one-dimensional, right? 4 plus 4 is only one way. You can't do a minus 4, right? You can't do a minus double because then you get 0. So what do? Now we know that if we want to add the 4, I know this concept. I know this concept. This concept is plus the 5 minus the 1. So I have 4. I want to add another 4. I'm going to plus the 5, take away the 1. My final answer is 8. So what did I just do? I just showed you three different ways on adding a 4, but it's the same way. There's the concept and we just compounded. So if we know how to add the 4, we can take away the 4. So if I have 7 or if I have 8 and I take away 4, notice all I got to do is just move the beads. This is the number pattern. I add the 4, I take away the 4. Add the 4, take away the 4. It's a number pattern. And that's the interesting thing about the abacus is it shows you number patterns that we don't see it in the mainstream math. We don't see the number patterns. When I add the 4, take away the 4. When you know how to add, you know how to take away. Same thing with the 3. If I have 7, I want to take away the 3 minus the 5 plus the 2 plus the 5. So let's do that again. So I'm adding the 3. If I want to add the 3, I have 3 plus 3, right? Plus the 3 is what? Plus 3 is equal to plus the 5 minus the 2. Plus the 5 minus the 2. My final answer is 6. Does that make sense? So those are the basics. That's the basics. That it seems a little bit overwhelming. No, it's not overwhelming. Is it overboard? No, it's not overboard. You know why? Because now we can be more versatile. Let me give you a bigger question. How do you get 6? No, how do I get 6? 3 plus 3. I add 3 on my abacus. Can I add another 3? I don't have enough beads to add the 3. I only have 1 bead left. I have the concept 3 plus 2 is equal to 5. Why? Because I want to utilize this 5. Add the 5, take away the 2. My final answer is 6. 5, 6. Let's do it again. I have 3. I have 3. I have a nickel. I have 5 cents. I have a nickel. I have 5 cents. I don't have any more change. I only have 5 cents. I'm going to give you the 5 cents, but I give you too much. I need money back. You need to give me some change back. I give you, because I'm only giving you 3, but I only have a nickel. So I'm going to take away 2. So that's how I get 6. Does that make sense, Joe? Yeah? Oh, hey, Alyssa. I didn't see you there. Welcome. Thank you so much. We can't see all the change. There's only 3. There's only 3. With the money, it helps. Yeah. Yeah, it helps because we know the value of the nickel, right? We know the value of a nickel. It's 5 cents. If I give you 5 cents, but it's only worth 3, you got to give me money back. Where's my money? Show me the money. So I take it back. So these are the 2, right? So this is mine. This is yours. Yeah. Okay. So that's about trading. I'm trying to erase my memory and relearn it. It's very difficult. And I'm not gonna lie, it's difficult. When I first started, and I learned it when I was older. I learned it when I was 30 or something. 30. I've been teaching this for 20 years, so that's how old I am. And so when I learned it, it was very interesting. I feel like Neo when they downloaded Kung Fu. I know how it is. Yeah. It's so fascinating. Like we don't need to memorize what 3 plus 3 is. We just need to understand this concept. If we can understand how to utilize the 5, what we're trying to do is we're trying to utilize this 5. We're trying to make sure that this 5 is no longer freeloading. We don't want any freeloading numbers, right? So let me give you another example. right? A bigger number. Because some people are like, this is too easy. Okay, that's fine. But when we talk about this, right? Let's do this one. I'm getting, I'm giving that I'm a practical learner. This helps me ton. Giving that I'm a practical learner. This helps me ton. Oh, good. Fantastic. Yeah, no, it's helpful to know that you're trying, right? Because I only have text, right? I only see the comments. So knowing that you guys are genuinely trying to understand, then it helps me continue to explain it. So here's another question, right? We have 1, 3, 5, 7, 8. Then what do? We can do 2. Can we add 2 here? Yes, we can. We're going to add the 2. Add the 4. Can we add the 4? No. How do we add the 4? Do we remember how to add the 4? Add the 4 is plus the 5, thank you, Trip, minus the 1. So what we're going to do is what? We want to plus the 5 minus the 1. Plus the 5. So these are directions. Oh, Joe, that's another thing. This is giving you directions on how to do it. Add the 5, take away the 1. Bring down the blue minus the orange. Yes, right? And then we can add the 3. We add the 3. 1, 2, 3. We add the 3. And then we add the 1. And we add another 1. So then our final answer is 37,889. So what did we just do? It's a very simple problem with only one of the 5, right? But that's why, so you can't add, I'm sorry. That's why you learn the basics. This is why you learn the basics. Can you do the same problem but 23? Yeah, let's do the next one. So if you can't add it, you subtract it? No. If you can't add it, you use modification. You modify. You add the 5. You utilize the 5 if you cannot add. If you cannot add it, you utilize the 5. If you cannot utilize the 5, then you utilize the 10. Twenty-four, 313. Hey, Kyler, welcome back. Hello, Cookie. 135. Okay, so then what are we doing? Are we doing another? Are we doing this one, or this one? Pancho? I'm well. I'm tired. Okay, so this is more complicated. The top plus noon. Oh, I see. Okay. Sorry. 1, 3, 7, 5, 5, 7, 8. 4, 3, 1, 3. Okay, so we do 1, 3, 5, 7, 8. We have to take it. I agree. It gets tiring these days. Yeah, it does. It does. But yeah, I think. Oh, I got to do one more. I'm going to do this one, and then I'll do a multiplication, and then I'm going to end the live. I'm going to regroup a little bit. Yeah. When I get like when I can't decipher what's going on. Okay. Sorry. Let me do a little bit of cleanup. Okay. Add the 2. Add the 2. Add the 4. We know how to add the 4. Plus 4 is equal to plus the 5 minus 1. Plus the 5 minus 1. And then we're going to add the 3. Yes, Joe. Good. Add the 3. Yes. Add the 1. Yes. Add the 3. We're going to add the 3. We're going to add the 3. Can we add the 3? Plus the 5 minus the 2. Plus the 5. No. No. No, we can't. What do we do? We have to use this one. Plus the 10 minus the 7. Plus the 10 minus the 7. Plus the 10 minus the 7. So what's my final answer? 3, 7, 8, 9, 1. Thank you guys so much for liking the live. Does that make sense, Pancho? Thank you, Trip. So it's this one, right? It was these two. This is a plus 10. I'm sorry, this is a plus 5. That's a plus 10. That's how I see it, right? These are simple. We go one number at a time. Yeah, yeah, only go one number at a time. Do they allow these in testing labs? I think they do because it's helping you track your numbers. You have to ask. But from what I remember, there was a few people that said you're not allowed to have calculators. They ask if you're allowed to have a abacus. You know why they are allowed to have? I think they're allowed to have abacus because they use abacus um, for learning people who have learning disabilities. I was with you when you were at the minus the 5 plus the 2. You're not allowed a calculator in college. This is not a calculator. It's a tracking tool. So you're allowed to bring an abacus to you're allowed to bring an abacus to college because they use it for learning disabilities. I was with you when you were at minus the 5 plus the 2. Ugh, no. Minus the 5 plus the 2. Can we minus the 5? Can we add the 5? We cannot add the 5. We can't add the 5. So if you can't add the 5, you got to do it a different way. Can we try a division problem? No, I understood. Oh, okay. You want to try a division problem? I'm gonna have to try a different day. I'm pretty much spent. Yeah, not yet. Yeah, I'm pretty. I've been on for about 2.5 hours. So yeah. Oh, I really like how you use the nickel. Oh yeah, and the pennies to show how the formulas work. Thank you. I appreciate that. Let's do another problem. Another. Do that other problem you had. Excuse me. Yeah, yeah. Thank you, Pancho. I am gonna end the live. I am getting quite tired. Yeah, thank you, Trip. No, thank you. I thought you had one more for us. It's multiplication. Teaching children. Thank you for your patience. Like teaching children. It's different teaching children. Well, multiplication. 24 times that by 8. In abacus, we need to count our digits because we need to know where we're going to put our answer. 1, 2, 3. 1, 2, 3. So what we're going to do is we're going to do distributive property. Distributive property is a algebraic term. Distributive property means I'm going to do 8 times 4, 8 times 2. 8 times 2 is equal to 16. Add 1, add 6. 8 times 4, why? Because I do this one. That's next. 32. Add 3, Add 2. Is it 16? 36? No. Yeah. 32. So my final answer is 192. All right. Let's I'm spent. I'm sorry. I do need to. There's your yeah, that was the multiplication. Thank you, Joe, for your patience. But yeah, I am pretty spent. Thank you for the follow. Expand the angel, right? What is it? It's over this one. It's the oh no. You healed my childhood. What? Great. I needed this when I was a kid. Yeah. Yeah, I needed this when I was a kid too. I don't know why we teach the children to multiply to know your Toa timetable. It's so not good. In abacus world, we only need to go as 9 as high as 9, right? We c- at a later time, depending on how far we move the class, we can do division. It's a little bit of a process, but once you understand the process, it's a lot easier than regular long division. We still do long division in abacus, but we do it a different way. Just so you know. But yeah, I can't do it right now. I'm pretty much spent. But thank you guys for joining. Thank you for all the comments and questions, and thank you. I was trying not to. I was I'm not afraid to say I was not good at multiplication. This would help a lot. Yeah, I will follow you and tune in. I want to master abacus. Oh, okay, great. Yeah, yeah. And some of the questions when they're asked, depending on where I am, we're not ready for division yet. It's very much very procedural, right? And so if you understand how to do the procedures, then it'll be easy to do the division. It's just I I pretty much spent. Okay, I'm sorry. Yeah, if there's any other questions, I will have to keep a note of it, and we will do we'll do more advocate, or we'll do more excuse me, arithmetic later. Oh, good. Thank you, Joe. No, thank you for your patience. I sometimes I'm a little bit abrupt because I don't know where the people are coming from. You know what I mean? So sometimes when the questions are asked, I don't know if it's like a dig or not. So I appreciate your patience with my aggressiveness. I'm, yeah, thank you. No, thank you. I do appreciate it. But as long as so in the next time, depending on where we are and how big the class is, we can go into division. But for right now, oh, excuse me. Yeah, learning multiplication is good. I hope there's notification next time you're on. There is. There should always be if you follow me, there will be a notification. I try to go on. Oh, you're a human responding to text with no emotion. You are a human responding to yeah, exactly. Oh, before I forget, next week I'm out. I'll be out at science camp because I've got kids, and so I'm chaperoning science camp. So I won't be around all next week, just so everybody knows. Just so everybody knows, I'll I might I don't know if I'll come back on Friday, but I'll be back on the weekend for sure. I need help. I don't understand. I'm sorry, Sophia. You're going to have to follow me, and you'll see the next live because I am spent. Thank you, Joe, for your patience. I do it. Yes, it exactly. And yeah, thank you. I'll leave it at that. But yeah, thank you guys. Thank you for the follow. Thank you for the follow, Sophia. I will when I come back again. I need to recharge. Hey, Shane. I'm just about to leave. I'm so sorry. We were just doing some multiplication. Oh, excuse me. Yeah, I need to regroup a little bit. Thank you guys. Thank you again for all your support and all your questions. and all your questions. I will see you guys all in my next live. Have a good one. Bye. Yeah, thank you, X-Men. I bought the abacus. I have the instruction book, but there's a part I'm stuck on. Where are you stuck? Now I'm curious, Sophia. Bye, Shane. I'm sorry, Sophia. Where are you stuck? You bought the abacus. I have a instruction book. Do you have my instruction book? Or do you have somebody else's instruction book? Here's the question. Someone else's. Okay, that's fine. What was the question? What are you? Thank you, Pancho. I'll see you next time. Products in the carts. Oh, appreciate you. Yeah. Yeah, thank you. No, I appreciate all the help. I do appreciate the help to remind me to review. I'm just waiting for Sophia. Now I'm just curious. It's a problem. I don't know if she's here tomorrow. Okay, yeah. I'm. Yeah. All right. You're right, Joe. Oh, there she is. It told me to add one. I didn't have enough beads. Now it's asking me to subtract four with the current bead and add to the next one. What's the question, Sophia? I think I know what the question is, but I need to. Like, what's the actual question? And I can tell you what it's talking to you about. I don't think it's subtracting seven. I don't think it's subtracting four. Seven. So let's see. Yeah, what's the specific question? How do how would I, it's seven, but how would I just know that's four? No, no, no. I need to know the question. Yeah, the what it's saying there doesn't make sense. So like, is it? I don't know what the question is. Seven plus three, or seven? Is it seven plus four? Is that what the question is? See, X-Men knows. You know. It told me to add seven. Is that the question? Seven plus four? 11? Oh. No, Sophia, what's this? What's the question? Is it seven plus four? Yeah. Or is it seven plus seven? Seven plus seven is different. Or is it seven plus six? Seven plus six. Oh, I see. Okay, that's what I'm waiting for. Yeah, I need to know what the question is, or that I could explain it, and then that will be my. And then for sure, that's my last one. Oh, excuse me. Yeah, I'm just waiting. I'm just here. Cleaning. I need to clean my stuff. I'm just curious. My curiosity is piqued. Yeah. This is the live of just yawning, of me yawning. Welcome, everybody. Let me show you how I yawn. Uh, all right, Sophia, how about you text me or message me or find a post and leave a comment and I can figure out what you're trying to say. Um, I don't be wasting everybody else's time. All right, Sophia? Okay, Sophia, I'm gonna end the live. Oh, there it is. Oh, okay, got it. Okay, sorry. Are you a No, I'm not a math teacher. I'm an abacus teacher. See, that's a bigger question. So we have 3, 3, 4, 5, 6, 7, 8, 9. Right? 3, 3, 4, 5. Right? The first thing we're going to do is we're going to add the 6. Is there enough to add the 6? Yes. Add the 6. Right? How can we not love? Sophia? I'm still on. I got curious with this one question. This is my last one. This is my last one, Beal. Sophia, this one here, plus the 7. Plus the 7 is not enough. I see what the problem is. Plus the 7, right? Plus 7 is equal to plus the 10 minus 3. I'm going to plus the 10 minus the 3. So, Sophia, I'm going to minus the 3. And then what do? I plus the 10. Can you plus the 10 here, Sophia? How do you plus 1? How do we plus 1 here? No, you can't. How do you plus 1? Plus 1 is equal to minus 9. Yes. Thank you, X-Men. Minus the 9 plus the 10. Minus the 9 plus the 10. Right? The green. Yes. So we're done with this. We're done with the 7. Right? We're done with the 7. Does that make sense? And now we're going to add the 8. Can I add the 8? Thank you, Beal. Yes, that's it. Can I add 8? How do I add 8? No, I can't add 8. How do I add 8? Plus 8 is equal to what? Minus the 2 plus the 10. Yes, thank you, Trip. Minus the 2 and then plus the 10. My final one is what? 9. Yep, 9. I want to add 9. Add the 9. How do I add the 9? Add the 4. No, no, not add the 4. Focus on the problem, right? The first thing we need to know is we need to want to plus the 9. Plus the 9 is what? Plus the 1 or plus the 10 minus the 1. Hey, Jessa, that's how you add the 10 and the 9 minus the 1. Yes. So we want to plus the 10 minus the 1 plus the 10. Okay? We're going to plus the 10. We're going to add the 10. Now we need to minus the 1. You're doing too many steps, Sophia. Now we minus the 1. How do we minus the 1? Yes. Thank you, Beal. Yes. Minus the 5 plus the 4. minus the 5 plus the 4. Oh, plus the 4. Thank you, Joe. Yes. Yes, X-Men. Left the 5 bead. Yes. So my final answer is 1, 10, 10,134. I'm getting it. Yeah, see? That's what I'm saying, right? Like it blows my mind. Is that the right answer? 10,134, right? Yeah. But see, that's the thing. You got to take it small. You have to take it each number at a time. Don't do too many numbers. One number at a time. You do the 10, you do the 1. If you can't do the 1, then you do the. I just started today. I just started today. If you just started today, this would not be the question I would start you on. This would not be the question I would start you on. This is a very difficult question. It's more advanced. I don't know what kind of abacus or book you have. Um yeah, I wouldn't. This is a bigger question. No, it's fine that you're doing it on your own, but the question themselves should be better curated is what I'm saying. It has nothing to do with, how you do it. It's great that you're doing it on your own, but this is a bigger question. I want to learn this. Hey, Taydor, Dior, Dior. Thank you for the follow. Sophia, does that make sense? This question is actually more intermediate. I wouldn't start you here because it's a lot of formulas. That's why. You know where I would start you? If you're really, I would start you here. We know this one. 1, 3, 5, 7, 8. Then what do? We add 2. We add 4. Add the 4. That's kind of hard, right? Add 3. Add 1. Add 1. If you teach from scratch, I'll be here every day. It's kind of hard for me. You know why? Because there's a lot of steps. There's a lot of steps, Beal. So that's why that book threw her into college level. Yeah, yeah. There's too many. There's too many. I want to know what book this is, but I mean, I start off with the simple, right? And I do it with diagrams. I do it with and you can color by number. This was one for kids, right? I was gearing towards kids, but this is like Neo going through the same door. So I was trying to make it interactive. I don't know if you can see it. There we go. Yeah, I was trying to make it interactive, and I have answers. I have that, and then I have this, and this is cool. So this is my puzzle. Answer the puzzle. Find the puzzle. Answer puzzle piece. How much for your book? This one? This one? Okay, so the way I broke it up here, the way I broke it up, just so you know, I have a series. You can find me on my TikTok shop. I think this one's like 11.99, I think, or whatever. This one is another 11.99. You can find some of my collection over here. Hi, my name is Lynette. I have been teaching abacus for 20 years. I'm in the process of building out more abacus books, um, and to be more digestible. I'm still in the process of creating a abacus for adults. I have others, so I'm still in the process of making more. I have this one where it's a bead recognition, so it's a little thing. It never ends. Vote for TED Talk. This is what do you call it? A maze, right? Figure out the number, and then you follow the maze. Yep. And so this was a reverse maze where you get the number, you get the number, and you have to color it in. So mazes. I love the mazes. Yeah, you like the mazes? I haven't done the three digit yet. I'm still in the process of doing 3 digit. So I finished the minus the 5. So there's plus 5, there's a minus 5 that sits here, there's a 10, and I got to do minus 10, and then after minus 10 there'll be the two-step equations. The two steps. I just haven't done it yet. Yeah. I'm trying to flush it out. And then after I finish my curriculum, I'm going to do it by grade. I'll do grade 1, grade 2, grade 3. And I think I can go to grade 5, because grade 5 I think is 6 digits, 4 or 5 digits with 4 or 5 add-ins. So, but yeah, I just started my path on putting abacus on the internet. Thank you. Thank you, Joe. Which one should I start off with first? Honestly, I would start off with this one, how to make a 5. And there's like activities until you get tired and bored, right? And then after this, you learn how to minus the 5. So I wish I was this passionate about something. I can hear your tone and how passionate you are. Oh yeah, thank you, thank you. Even though I'm a little tired, yeah, I feel like that there's a logic behind it, and I think if we just had a system to teach children to do math better, I think we won't have the problem of having more complex math. I always watch her lives. They're so fun. My brain's tired. Yeah. Oh yeah. Yeah. Thank you. Thank you. Hello, Tiffany. Yes, I will. Sophia. So just so you know, I do go live almost every day. Next week I'm taking a little. I'm going to science camp. But I'm starting to come down a little bit. But yeah. Thank you, Joe, for all your patience. Beal, thank you for coming back and all your support. We need more people like you in this world. I hope so. I hope so. It's nice to hear the support, and I do appreciate all the support that you guys have and all the compliments, because it does help. It does help, knowing that you're not anxious about math, because you shouldn't be anxious about math. But the greatest thing about abacus is it shows you the pattern. So okay, I am going to end the live. I've been on for 3 hours. I'm a little tired. Thank you guys. Thank you everybody. Sophia, I hope to see you in my next live. Thank you everybody for joining and commenting and being patient. Thank you, Tiffany. Yeah, have a good night. Have a good night. Bye, Neon. I didn't know you were still here, Neon. Oh, yeah. Yeah, next time. I've been on for a little bit. Thank you, Joe. Thank you, Joe, for all your patience. I do appreciate it. Okay. Always. Oh, Neon. All right. Have a good one. Have a good one. Thank you, guys. Thank you. Bye. Oh my God. Ugh.